let's continue here. Let's see, last time yeah, we continue with the imports, and the execution of the import works now, and we get a scope, but we just need to wire it up to the identifier and being able to like refer to things in the scope through the like a member access or something like that. We already have like something like that. I'm gonna look at how that would be. Probably member access. I think we have something like that. Member access. Is this a expression? Yes. And where? Oh, I see. So this is, no, this is like the old thing. Yeah. This would not work. Well, I mean, okay. We have to, I think we have to sort of extend the parser. I mean, yeah, because if you go, I don't think we have member access yet in the new parser. So if we go to like test, and then we say, for example, if we go to lib, well, it doesn't really matter if it's gonna be like a real thing or not. I'm just gonna look at I'm gonna look at the AST or maybe even the tokens actually. Yeah, okay, so we do have a dot token. I think, yeah, the AST is what's preventing us here from, yeah, expected start string start got dot. So yeah, so we need to figure out that. So let's go to the parser. And we have like parse expression, I guess. All right, so we have a couple of different expressions here. Import, identifier, if. Now the identifier, yeah, it's probably gonna be like, actually, you know what? Like member access should probably have precedence. Because it could include this here. So I think member access is probably, we want to try first. Like, okay, so the identifier expression, so this path is basically just checking the next, we're just checking the next token and looking at what path are we gonna take. An identifier is basically saying, okay, well, this should include any path that starts with an identifier, which should include member access. However, member access could be other, you know, you could have a parenthesis with some arbitrary expression in it, and then a dot after that. That would also be a member access. So it doesn't have to start with an identifier. So I don't think like this way of doing it, like peeking the next token, is and then deciding like this, doesn't really fit the pattern really. I think you want to like parse with a parser that would consume like everything. Like that's the or like first, the original parser function, like the first parser function that you call, that should like consume everything. And on its way to do that, well, okay, whatever. Let's just Because instead of doing this, what I would like to have instead is like, you know, one-off or choice, or you know, that kind of thing, and it's going to be one of these expressions or something like that, instead of just checking the next token and then deciding what to do here. This is not really how I'm used to doing things. So question is, I mean, it's probably, we could probably just do that. I mean, what if you have like one off? Now we're back to like the combination. I mean, I could pull in my other like library that I did for parsing, but then I would have to like redo everything in that thing. Okay. Because the idea then is that you would try a member access first, and if that fails, you would try something else, and if that fails, you try something else. So along the way, you would have consumed a bunch of tokens, for example. Then you'd have to rewind to your previous position and try something else. So that is kind of what I was thinking about. This is a little bit different. But anyway, let's just keep doing this pattern, I guess. I guess for now we'll only support identify expression, but in the future an expression could be, you know, surrounded by parentheses, for example. You would have like an expression in the parentheses. We don't have support for that right now, I don't think. Unless we have like, well, here we have like L parent, so well, I guess we do have support for it. Okay. Okay, well, anyway, let's do like identify expression, and yeah, so here's like, we're looking at, so we have the identifier, except we're trying a pipeline first here. Which could still be the case, I guess. We could still have a pipeline and then the member access after that. Maybe? No, maybe not actually. It's so hard to think about in this way, because you need to like look at the next one and then decide what to do. I think it's much easier to test one parser, then rewind if it doesn't work, test another, rewind if it doesn't work. I mean, we have a way to do it. It's just that if I start to write one off here, I don't think this will pan out. Well, okay, let's just do it. And it's gonna be some sort of actually, you know what? We could support multiple yeah, actually, let's do this, because I was thinking like the result type, what would the result type be? We could actually construct a result type. Okay, this would actually be an upgrade. My previous like library for parsing with the monadic combination library for parsing, the one-off actually had to only have one type to return. But this could potentially have multiple expressions, or I mean multiple results. If you pass in, so okay, you pass in a bunch of parsers. This is going to be a like a tuple of parsers, and then the result. What is the result going to be? Because any of this, the one of okay. What this function will do is we'll take a bunch of parsers, try them one by one, try the first one, If that succeeds, it will return the result of that parser. However, if it fails, it's gonna pick the next parser, or it's gonna try the next parser. It's gonna rewind also the entire machinery back to the starting position, and it's gonna try the next parser. If that parser succeeds, it's gonna return that parser, and so on. If everything fails, then this parser fails as well. But I was thinking, like, if you can't just have, like, here, you can't have like any type in the returned type, because Sig doesn't support that, and then return whatever is gonna infer it. That doesn't work. What we could do though is, and the solution I had last time was that I had like a comp time t, so that you would supply the type that you expect from this list. But then that constrains all the parsers to have the same resulting type, right? Because you're only returning t, so everything needs to return t. And in this case, you know, we're probably only expecting an expression like this, so it's fine, I guess. However, you could also do this. One of, so I will make a new function for creating this type, and we'll pass in parsers. And what that's gonna do is that we have this one-off function. We take in a comp time parsers type, and this will return a new type, which will be a tagged union, or it could be, I mean, okay, maybe it could be a tagged union. I was thinking first, like, that you would get a type like union enum, and it would be like, you know, first type, like first result type, which would be, you know, type of parsers 0, you know, something like that. And then the second type, so something like this, or yeah, the result type, something like this, you know. But and then I also thought that, okay, well, what if those types are the same? Then you could like smash them together and have just one type, so you would have like, I don't know, expression, something like this. However, I think that we should just keep this structure here, because then you could, even if you have the same type returned by multiple parsers, for example, you could still differentiate and do some logic based on which parser was successful there. Okay, so I think we will do that. So we will basically construct a union type, which will be, so how you could do that is you return a type, and then this is actually just a definition of the type. So this would be a union, wait, what is this called? Is it just a union, and then it's like tag type? Yeah, so it's a union with the tag type, and then this is an enum, which is gonna be, it's gonna, I mean, it's basically gonna be the same as parsers here, I think. We could also make a new enum that takes like the names of the parsers, maybe. That's gonna be maybe kind of hard to do, because the tuple here doesn't know about the names. So we would just have to use the tags of parsers because we're getting a tuple in. This will be, actually, will this work? Yeah, it's getting the fields, and the fields of a tuple is a struct fields, and the names are gonna be just, you know, 0, 1, 2, 3, and so forth for a tuple. So we're gonna have a union that has 0, 1, 2, 3, depending on how many, you know, if you pass in this like parse int, parse string or whatever, then you're gonna have like 2 tags. You're gonna have, this is a tuple, this is element 0, this is element 1, so this has a field with a field name is actually like this, or, well, this is how you define it. So this is kind of the same thing as a tuple, I guess. I wonder if this will actually define as a tuple. But this is how the fields would look. If we do this. So this would be like equal to that, basically. And this tags here will be these tags that we get. So this union result is going to have the same number of elements. All right, and then we need to also construct the fields, which is going to be a you know, fields is going to be a list of constant union fields starting with an empty string, or an empty array or slice. Okay, then we need to loop through the fields of parsers. We don't really need a field. We can do the tags as well, but whatever. We get the fields, and then we do yeah, so we could get like the parser is gonna be field. No, hang on. No, yeah, it's gonna be field type. So that is the parser type, right? And then we can get the return type of the parser by you doing type info parser, because this is a function, and this is gonna be function, and then we're gonna have return type. And if this is also like a thing in zig-like, the return type can be this can be optional. If it's optional, that means it's a void. So I like to do this when defining that. Okay, so now we have the return type of the parser, and we can go ahead and just say field type here. Okay, now we can add our field in here. So this would be fields, and we append a built-in type union field array, and this is gonna be, so we have basically, now the LSP doesn't understand that this is an array, so it thinks that we define this inside this here now, but the type of the field is going to be the return type. The name is going to be field name. It's going to have the same name. and alignment. I don't know really, but we'll just take align of return type. All right, so now we're constructing the fields of this union here. Each field will have the type of, which is going to correspond to return type of the parser that you passed in. The name is going to correspond to the tuple sort of element like 0, 1, 2, 3 and so forth. And alignment is okay. Okay. So now we have constructed this type. So if we, for example, pass in this type, we will, what you will get out basically is a union enum with 0 being you know, an integer, I guess, and then 1 being a string, basically. So that's what this function will do. It will take in this, look at the return types of these functions, produce a union enum with the same elements, but the return types are here instead. So it's basically mapping the tuple into a tagged union with the same elements and taking the return types of the functions. Okay, so now we have that as the result. So the result will be then one of these elements because it's a union enum. And what we need to do here is we need to loop through all the, so just inline for fields of parser type of parsers, and then I'm not sure if you can like you can iterate on a tuple like native, like you could just do parsers. I'm not sure if you can do that actually. What if you do let's say I have a tuple here like 1, 2, 3, 4, and now we'll do 4 x's. Will that work? I don't think so. No. Okay, so let's, but we can do this. We can get the type, we can look at the type of this, iterate through all the fields, get the field out here. Then we get the parser by doing @field parsers field.name. So now we extract the parser from the tuple. And now we just have to do like, we have to have some kind of, what we'll do is we have a snapshot. Take snapshot. I'm gonna make a new function for this because I have like an interface, kind of like, no, not breadshots. Yeah, see here, we're accessing stream directly here, but I want to avoid doing that. Let's look at next token. That's not public. Right here. So here I want to do take snapshot, and this will return a snapshot. Yeah, it's just a stream. Where is this? Lexer or? Yeah, I think it's Lexer stream. So that just returns a snapshot, and then we want to restore snapshot. Snapshot. We will say stream restore snapshot. Yep. Okay. Initializing array with struct syntax. Oh yeah. We need to do this. There we go. Hello, Con. How's it going? Parser snapshot. Okay, so now, good, great. We will parser snapshot. What are we doing? So we want to. Yeah, so we take a snapshot so that we can restore it later. And now we can basically, actually we could take the snapshot out here. Well, whatever, let's just do this one by one here. So we will do parser, we will execute the parser, we will call the parser has to have the exact same makeup basically. So we will call the parser with self, because that's how the parsers work here. We don't have parsers that take arguments. Well, I guess this one does, but that's not the same thing. You have to pass in the same kind of parser. So you have to pass in a parser that takes just one function, like it's like self here. Okay. Actually, I think we need to call try, right? Yeah. So that's this is kind of the signature for the parser. You could also like have a comp time check to check that it has this type, like the return type is this, with some sort of type here, and this is the error. But the compiler will complain anyway. Like if I have to say like parse error here, one off. I guess the error type, I don't know. Yeah, the error type is probably baked in here. So we probably need to extract the error, like the inner type from this, actually. So this is the return type. Now we need like the payload. And that is gonna be type info, return type, error union, and then the payload. So there's the payload, and that's what we actually want. Yeah, because that's gonna be the result of the one-off call, and here we take care of the parse error, and we funnel it through back there. So if this fails, actually we don't try. Actually, you know what? We don't try. We catch it. And we will yeah, we catch it. Let's throw away the error for now. This is where it kind of gets hairy with error messages, because if everything fails here, then which error message do you show? Like, but yeah, the way this parser was written before, it was easier to deal with the error messages. But once we introduce this kind of thing, then it gets a little bit more complicated. But yeah, so we catch that, and we also want to have the result of the parser. We catch it. If there's an error, we will restore the snapshot and then just continue here. Except you can't have continue in an inline for, I don't think. which is weird, but yeah, I think that's the case. Anyway, we need to take care of this. So the result is then, if we get here, then we have a result. So we can, now we need to return, this union type one of, right? However, how do we do that? You will have to use something called union init. And this is like a way to create a union value when you like don't know which tag you have or something like that. So basically the union type is going to be the same type that we want to return, type of parsers. And then the field name is going to be this. So we already have the name. That's going to be the same name. And then this is the inner expression. So this is the inner like expression, which is the result. There. Yeah. So it looks a bit complicated maybe here if you're not used to like comp time stuff. But basically, we're taking the parser out. So we're passing in a tuple of parsers. We're looping through all the fields of the tuple, all the elements of the tuple. For each element, we grab out the parser using @field, parser's field name. We create a snapshot. We try to run the parser. We get maybe a result out. If we get an error, then we restore the snapshot and we continue on to the next parser. But if we get the result, we are now down here, and then we create our result, like our one-off type, which will embed with the information about which parser actually succeeded. So if we now use this here, for example, we don't actually need to peek on the next token. What we will do is we will just try. Let's see. We will. How you could use this is you could say self one off, and then you put in a bunch of parsers here. So let's say we have like identifier expression. So you pass this in as a function pointer basically, and then. And if we just do this, then the result of this, so we could do a switch on that, and then we only have one result, so this is going to correspond to this result here, and we get the identifier expression out here. Now the LSP doesn't have no idea which type this is. So this is like the downside also of this. So the LSP doesn't know which type this is at all because of the comp time magic stuff we're doing. But the compiler knows. And so, well, in this case, this expression is actually just an AST expression, so we could just return it straight away. But this is how you could use this this function, and then you can pass in anything else. You can pass in if expression, and then this would be the if expression, and so on. So here we can actually support different types, different resulting types in this one-off here, because we can get each one out in a different branch out here. So that's pretty cool. And yeah, this one complains now. You get these sometimes when doing comp time stuff, which can be a bit tricky. Has no field name, has no member named 0, so we're trying to access. So if I run like zig build, I get more well, f reference trace. I get more call stack here, or not call stack, but you know. Let's see here. So we're trying to parse a let. No, wait. So parser, one of the parsers. So yeah. So this happens in tags parser. So 288. Yeah, so it doesn't like that parsers that we're trying to do a tags parsers. Apparently. What you could do is, there's another thing you could do, field enum instead. There we go. So the field enum takes a type, like a struct, or it takes a struct or a union, and then it will take all the fields of the struct, and it will make it will make a enum type of those fields. So this is kind of looks like what we were doing, is making taking all the fields. If the length is 0, it just returns this trivial thing. If it's a union, it takes all, it like looping through all the tags and everything, and it creates the stuff. Okay, but anyway, there's some fields missing here. So layout is, I guess, auto. Declarations always empty, because there's no support of having like making declarations when creating a type like this, unfortunately. And I don't think it's ever gonna be possible. So, but yeah, because I read it in some issue somewhere. Okay, so here now we get this issue here: comp time control flow inside runtime block. So this is kind of weird. I don't understand why this is not possible, because this expands into one block for every field, like for one block for every element in this array that you pass it. That's the inline 4. Inline 4 will take this array and it will generate this block for every. It's like unrolling the loop. It's unrolling the loop here. So but when you do continue, it should know where to go, to be honest. But maybe it's not possible. I don't know, because it should just go to the next block. But yeah, anyway, I guess what we'll do is we'll do catch wait, how would we do this actually? This is my first time seeing Zig, and while everything you're doing seems nice and cool and explicit, the syntax looks really painful. How do you find the syntax? Well, you just have to get used to it, basically. I mean, the syntax is not really... I mean, yeah, it's like a C-like syntax, but it has a lot of its own stuff. I guess you could say like that. So a lot of the things like this at stuff is like built-in... You could say like built-in functions. I'm not sure what they actually call it, like built-in functions or something like that. And they are the at stuff is like, it has like a bunch of random stuff. So you just have to go and learn, you know, what you could do with them basically. There's things like you have mathematical functions, abs and sine and cos. However, there's also a standard library that has the same stuff. So I'm not sure why that is the case, but I guess, yeah, the math library has a lot of more stuff in it, but then this has like this. However, I will say that these probably work for vectors as well. Yeah, these works for vectors, so you could potentially create like an array and use this on the entire array, like or yeah, a vector. A vector is in Zig is just an array, but it has the vector type basically, but it's basically an array. So you would define like a vector, like let's say you have a vector. So at vector is also like a special type, so you could add, so this is basically defining an array. So let's say you have this vector, and now you can say cosine on the vector to get to like apply cosine on all the elements on it. I'm not sure if standard math cosine works on it though. I mean, it should. It has any type here, so it potentially could. Yeah, it just calls. Okay, it just calls at cos here, cosine. So yeah, there you go. Yeah, but you would have like, okay, I will say this. This is not really normal Sig here. What's going on in here is more. This is like a little bit of comp time stuff in here. So this normally you wouldn't see. It wouldn't look exactly like this. I'm using a more you could say more fancy Sig code in this place here, and this one as well. Here is more normal. Here's more normal code over here. There's not as many like. There's basically in normal code you wouldn't have a bunch of at functions. So this is more normal here. I mean, you see an at here, but that's just a way of describing this field name using special characters. So this field name would be whatever is in this quotation marks here. All right. Now, how would we solve this issue here, though? I'm not sure if... Like, it would be if we could do, like... We have the result, and then we do, like, an if. Actually, you can. You can do that. You can do if. And we can... If it works, we get the result out here. But if it doesn't work, we get the error here. So this works. No, wait, this is the yeah. There we go. So this is how you could do an if on, and we don't have to have the continue now. You can have an if on a error type. So this is like an error. This could return an error. But if it succeeds, we get the result out if we do an if here, and we can use the result inside this block. If we don't succeed, we can do an else and then potentially capture the error if we want. I think maybe we will store all the errors, perhaps. Not sure. I'll just ignore it for now. Yeah. We'll ignore it for now, and then I'll add like a to-do error handling. Expected type, optional type, found error. Wait. But this should work. You should be able to do an if on an error result. Maybe there's another issue here. Yeah, we'll do try, actually. There we go. Okay, I'm not sure why we get this error now. I'm pretty sure you're supposed to be able to do if on an error type. Or error union. That's weird, actually. I've done this before. I mean, I'm probably missing something. Wait, is it because I'm not saying error here? No, I'm not returning error. I'm just doing this. Oh, I see. So you have to have this. You can't omit this if you want this to be like an if error. Okay. That's good to know. So that's how you learn the syntax. Let's see. Function with non-void, return type. Okay, yeah. It's complaining that we're not returning an error now. So maybe we'll just keep like the last error. I'm just gonna do like super simple here. We're just gonna grab, we'll have some kind of error. Actually, you can also say any error, I think. And then we'll return this error. Except we need to actually set it here. So let's get... Oh, this will be like the error. What the hell? All right. Oh, I guess you can't use any error as a return type. I guess it makes sense because potentially you could say it's not like yeah, okay, so it's actually, you know what, in TypeScript that would have worked, I think, because you could have made the type an undefined or no, unknown. And then along the way, it would have, if it analyzes that it has to be set to this some kind of error here, it actually would have narrowed it down. So at this line of code, the type of error would have changed. But yeah, whatever. This works. Okay. So we're just, if something goes wrong, if everything fails, we just take the error of the last error and return that, basically. Okay, so that's all of those errors there. So now we have a one-off function that we can use. I think though one thing that will not work here is like the expected tokens thing. But I will just ignore that for now. We'll get some weird error messages basically. But now we can do like one off, and it's gonna try each one from top to bottom until one fails, or until either one succeeds and then we get the one out here, or everything fails and then this fails entirely. All right. Okay. Now, this is like how I did it before. I think we probably want to do a member access before. So let's actually do that. Well, we could put all these instead now in here. And this would be like import expression. So I guess what you could do also is just say, since these are all expressions, these are all the same, you could just do, you know, else result, return result. You have to do inline else, I think, to get it. Or maybe not, actually. I'm not sure. Okay, that seems to work. And then I'm gonna remove this. And then we can just do like return. Actually, we can just do this now. There we go. Okay, so we're doing like one of these. Whichever one succeeds will just return. Now we can do this since all of these return this type. So if one would return something else, what you could do is you could say, okay, let's say the third one returns something else. So you could say, you know, 0 or 2, which would be third one from 0 index. And then you would get the result here, and then you would do like 2 expression or something to, you know, make it into an expression or something like that. So you could, but you can still keep this to parse the rest as expressions. Okay. Okay, so we've done this. So now what? Well, what I want to do now is first I want to try a member access expression. So that will have top priority. But there's an issue now as well, which I will come to later, because member access expression will ultimately call parse expression again, which will go in here and try this again, and so on. So we have to fix that as well, and I forgot exactly how I used to do that. No, that's fine. I like it when I get questions here. When you have the parse error syntax in the type, I assume that means a parse error in a member can be thrown. Yes. Do you have to explicitly return this error value, or is it an exception algebraic effect? If you have 2 different kinds of errors thrown, do you have to explicitly compose those 2 enums together? So this error is like it's an error set. So you can this actually is like includes multiple errors. If we go to the definition here, this is how you define an error set, and these are the actual like different kinds of errors that you can have. And not only that, but you can like create like a union, or you know, in set theory, like you can basically, you could glue all these errors together into one error type. And now this error type can have any error in here, and it can also have errors from the allocator or errors from this lexer here, which are all also like error sets. So it's gonna make a new, well, this now type will potentially contain errors from any of these here. And this one contains like all of this, and then you can have duplicates here without issues. Yeah. So that's how that works. So basically the error is not like parse error, like you return parse error and then dot, and then you get all these different kinds of errors that you can return. All right, well, let's just do the member access expression here. Is the try not actually a try, but instead shorthand for early returning error? I mean, yeah. It's okay. Let's see. It's like this. You try something that could error. Okay, that is the same as saying something that could error. So let's say you have the result, and then you have some kind of if result is an error. Let's say this doesn't work, but if let's say you have a magic, or let's say you have a magic function that looks at if this is an error, or maybe even well, okay, I will show you how you would do it. Actually, you would say something like this, and then you can catch, and then you get the error out like this, and then return error. So this is basically what the try is doing. Well, okay, we have to call it. We call this function. Catch will look at the result and see if it's an error or not. If it's an error, we capture the error here, and we can do whatever we want, but in this case we just return it. If it's not an error, then we just continue as normal. And this is basically what try is doing. It's like a shorthand for doing this. So yes. So it's basically, it's basically how you also could put it is that we don't handle the error here. You bubble it up to the caller. Errors can be implicitly union together. Right. Yeah. So you can also so if you have like a function, if you just do an exclamation, like if you say parse error, then you say that this could only return a parse error or nothing. However, you can also do this, and this will implicitly, the compiler will implicitly try to calculate which it will join all the errors that you throw here. Something that can error like something else. So now it would infer, yeah, that's the correct term. It would infer the error type automatically from whatever this call is here, or every try call, every error type in here. So all the errors are like statically sort of known, you could say, or like comp time known, or error types, I should say. But then you can also, there's something like you can take like any error as an input as well. I suppose that would be like kind of equivalent maybe to any type except for errors. But this basically, this is kind of like a special type that can be any kind of error. Yeah. That's a little extra chapter for errors. Hey Bruce Wayne, how's it going? Okay, so parse member expression. Let's do some breadcrumbs. So this yeah, so basically that we encountered the first issue here already, because first we would parse some kind of expression. However, this would call this again, so we would have it like an infinite loop. So either I'm thinking we make a new function for parse expression which like excludes this, or has like a special like we just parse like, I don't know. I don't remember how I solved this issue actually. Because potentially you could have an expression that looks like this. Like you could have a dot b dot c. So how would this work? Well, you would try to parse an access expression, which technically could be that we parse this as an expression again, which would look at, but now we kind of ban member access expression, I guess. And then we could look at this, and now we go down to like primary expression, which would be like the parentheses. So if we go in here and now parse expression again, and now we can member access expression. Now we're on this one, and so it would go down to identifier, and it would just be one identifier. And then this would continue with dot b, which would be like actually this would have to be an identifier, so because it's this is the name of the field or whatever. So that's that should just be an identifier. And then this one here, so we're done. And now we're at the outer member access expression, so we're .c. So I'm not sure how we would do this, like if you call a parse expression again, but now we ban this or something like that. I'm not sure. Any particular reason to choose Zig for this thing you're working on over Go or Rust? Now, I've just been using Zig for about a year, and I just feel like it's a really nice language, and I really like working in it. So I've never tried Rust. Like I've never done like anything real in Rust. I've tried, you know, a little bit, but I didn't really learn about, you know, the borrow checker or how to do anything, you know, basically. I tried to make like a web server, but I failed spectacularly because I didn't know anything about how the rules were or anything like that. So nothing I tried worked using like conventional programming. But yeah, the compiler yelled at me for a bunch of stuff. But I mean, I could go in and learn about the borrow checker and everything and all the rules and stuff and do it again. But I don't know. I just tried Zig and I just like it because it has like new ideas, and I love to like explore new things. And so Zig is like perfect right now because it's a new language. It has like the comp time stuff, and yeah, it's really cool. Am I from India? Oh, do I sound like Indian? That's interesting. No, I'm actually Swedish. There was someone also that thought I was from Italy, which also is interesting to me. But then I had someone from Scandinavia, which immediately picked up my accent and knew exactly where I was from. But that could also have been, you know, a red herring. Okay, how would we do this? Your name's Sunil. I thought you're from India. Oh, I see. Is that a name in India? Cool. Skål. Yes. Skål. That's my coffee cup. All right. Man, I always don't really know a perfect solution to this here. I'm just gonna read up a little bit on this. Let's see here. So we've got like, this should be like, what would this be? Combinate parser. Yeah, recursive descent parsers is not limited to constant critical arms. Not ambiguities. Yeah, maybe this is not the good way to do it. I don't know. I just tried to think about how to do it like this, but it just seems so complicated, and it feels like you have to repeat yourself a whole bunch. Yeah, this is kind of weird, like interesting. You know what? I'll try to do it the way we already have, because the thing is, it's gonna be easier, I think, with the error messages and stuff. But I think it's gonna be harder to define the parser though. But yeah, let's just try it anyway. Okay, so how would we do this then? I guess we start with identifier. So we just allow member access after an identifier. And so we will take the next token. We'll grab the identifier. We'll peek at the next token. Why are we restoring here? Okay, and then we'll do this. Hey, by the way, do you actually find these niche things good from return on investment perspective? Like, I found low-level things cool, but as someone at early stage career, it feels like this thing should be stayed away from and learn mainstream stuff like web work. Yeah, it's kind of like when you're new. I feel I've always had the opinion that you should learn like the easiest thing first, like just the theory, I guess, more. I mean, you can go, like I've been saying to people, like, yeah, you should start with like Python, and if you just want to learn programming and the concepts and everything. But then you also realize that it's not just programming, it's also like there's so much around it as well. There's like the tooling, it's like getting used to like a text editor, there's so many things, and then you're kind of learning, you know, one thing, and then if you want to sort of switch to another sort of environment and everything, it's going to be so jarring, I guess. Maybe, I don't know, but it feels like it could be a risk that the switch would be so jarring that it's gonna be super hard. But then also, like, yeah, if you want to become like an web dev, it's just go and start learning that route. You know, if your goal is to just get a job, but you don't, I mean, like if you know what kind, like in which area you want the job, then you should go for that area. Like you should go, because there are so many paths to go in programming. But yeah, I'm not an expert in any of this, you know, learn like this part. Like I've been programming for a long time and I have a job for 10 years, but you know, it's always hard. It's always such a hard question, you know, and when what to do now, especially in like the current climate and everything. It's harder for juniors now than it was when I started to get jobs. Yeah, my start was basically, well, I went to school for 3 years in computer science. So I have this, I went to like this bachelor degree thing. And but even before that, I was self-taught in C++ and programming in general. So, and what I did then was just looking at resources online, like look at tutorials and just learned how to do stuff. Because I was interested in making games, and so, but then I realized that, hey, I actually like programming a lot, and so I got a kick out of like just making anything, basically. And yeah, just the interest of learning was, I just improved my skills and everything. Then after school, it took a while to actually get a job. Like I didn't get a job like immediately. It took like a couple of years before I actually got a software engineering job. And then it happened to be a web development job because I just applied, and I took the first thing that I found, because I was thinking like, okay, well, I have to get my foot in the door somehow, and once that happens, then you know, you're good. When was the time start exploring niche stuff? I think I've basically done that all the time. Like I've always enjoyed making like anything that I found interesting, and yeah, it's just a hobby for me, like programming in general. What are you making this language for? What's the big idea? I mean, okay, the language is basically a toy language for my personal enjoyment to make, but it also could become a language that I would use instead of using something like Bash script. So that's the goal. I've been looking at like more Bash stuff, because the thing is, like, recently I've been learning Bash a little bit because I've been using Bash scripts more and more. But I can't get over the syntax of that language. It's horrible, and it's not consistent. I mean, all props to people who are good at Bash and enjoy doing it. Like, keep doing it, but it's like it's not for me. So I'm making a language to replace, to kind of do. I want like the same kind of ease of just making a script that calls a bunch of programs and you know, hobble things together and present some, you know, terminal based stuff, but it has like, you know, more consistent syntax, I guess, and maybe a type checker. I also have like an LSP here, so I have all the niceties, little bits and pieces, but they are very shallow right now. Scripting was a bit vague, yeah, but yeah, I have to put something there. Maybe if I put Bash scripting, it could be more. I mean, the scripting language, yeah, it's mainly interpreted, I guess. It's like, yeah, I could say that it's an interpreted scripting language that is, I guess, Bash-like. And well, the design is basically gonna be, I want Zig syntax because I like Zig right now. I want to have Zig syntax and Bash syntax combined, except the parts of Bash syntax is only gonna be around creating the processes and pipes and stuff. I can show you an example here. It's not complete. Like, the examples are not, you know, don't take things with a big grain of salt here, because this is not complete. The syntax is not properly completed here. But basically, wait. This is like the first sort of, this is like AI generated examples of the first, man, where is, yeah, pipeline. So, wait, where are the pipelines actually? There's no pipelines here. Oh, here we go. So basically like this could be possible. Now this is not a sub shell. Keep in mind, this is just a parenthesis, like keeping this in an expression here. I'm not sure how the sub shells are gonna work, but it's basically, you can see here, like you can call this just like any old bash script, pipe it, use these you know, executables, and possibly even you know, since Zig can interface with C, maybe we could also support bash, you know, the bash plugins or whatever they have, because they are in C, and yeah, so maybe that could be a thing. Hijack into that, I don't know. But yeah, so basically, and then now this will be set to this pipeline here, which means that you have everything in here. You have the exit code, you have the you know, the output, standard out, standard error, like, yeah, everything from this here you would put in, you have in here now. So that's the idea, and then you could use that later. Right now we actually have, let's see, if we go to our actual working code here, you can import this lib function, or I mean file in the same, so this is like relative to the script here. So you import this creates a constant name, which is like the result of this here, and then you can use this in this interpolation. This will take the standard out from this and put it here in this string here. So if we run this, we have to okay, I changed the wait a minute, I have to change the parser now because I have done some stuff. Let's do this again. Yeah, but you can basically see what it's gonna do. And are you even here somewhere now? Okay. But if we just do runic test, it's gonna say hello from lib. Now, yeah, so what I did was I started. This was also an experiment with AI tools. So I started with AI because I wanted to check like how good is it at Zig, and it turned out that it was using like an old version of Zig. It tends to like use the older version because the syntax changes and the standard library changes a little bit. But anyway, so the whole base foundation of the project was built in Zig, or I mean, it was built in with AI. And I just recently started to, because I realized that, hey, AI is not really doing what I wanted to do. So I started to just work manually now with it. And I rarely use AI now for this project. What programming language do you use to work? I use TypeScript and C#. But mostly TypeScript. All right. Let's see if we can get this member access in here. So what I'm working on right now is trying to make this work. I want to be able to access. So last time, like yesterday, we did the import thing. So that works now. And now I want to be able to access this declaration here. And in the future, we might have something like pub, you know, to make it public. But we don't have that yet. So I'm just gonna expose everything right now, and I'm just focusing on trying to make this work here. So you could, like, let's say we wanna echo this out here, for example. And if we try to run this now, it's gonna fail. It gets the tokens, but the AST fails, so we have to implement the parser. And that's what we're doing here. So when we encounter an identifier, we consume it. We get the next token. Actually, yeah, we could. Let's restore it. You know what? We don't really need a snapshot at this point because we could peek multiple things. Actually, we can get like, yeah, we could do this. Peek. Wait, didn't I have like multiple peaks? Maybe I didn't. Peak slice. So we have peak slice. I just need to expose it through the stream. Right. Peak slice. We will get tokens. And we need a length. Yeah, and so we just peak slice. Actually, then peaked would be not just one token, it could be multiple. Discord server invitation link is broken on your website. What? Oh. Okay, hang on. Oh, I see. There's like a limit. Okay, interesting. 1 second. See if I remember how I got there. Okay, here we go. Ah, I see. All right, let's see. One second here. Well, I guess I can show you what I'm doing. Doesn't really matter that much. Where would this be? Hero, probably. Where is that? Ah, components. There we go. No, that was not it. I have to go to Discord again. There we go. All right. I'm gonna test it now. Wait. Do you have to? Oh no, I have to restart the server or something. Wait. Do I have to? I don't have to restart the server, right? Where's the thing? This one. Let's see. Restart. Okay, I'll just do this. Stop. Build. I thought it would actually automatically do this, but maybe I haven't pushed those changes yet. Yo, Gianni Pakoda, how's it going? There we go. Now it's updated. All right. Now it should work. Sorry about that. All right. Okay, so yeah, so the peak, we probably want to have like, well, we don't need to have a list. We could just have like peaked length, which starts at 0. And to get the peaked token, you would just look at, if the length is 0, then we don't have any peak tokens yet. But if it's more than 0, we would just know that we could access the nth next tokens. So let's get rid of that. So right, so if peaked length is more than 0, we will decrease it, and we'll get the token by saying something. Oh, maybe we don't actually have a buffer for the tokens. I see. Right, we don't have a buffer. Okay. Or wait. We have like an index for the source, but we don't have a buffer. Okay, so we have to like make a buffer here for the tokens. Actually, so we can't just do this. We have to do like we do like a token buffer. Let's just do an array list here of tokens. And that should then include the peaked, this is like the peaked tokens. Peaked token buffer here. If we have anything in here, we will actually have to remove the first item. Yeah, I guess we'll just do like an ordered remove 0. That's the token. There we go. If we don't have one, we do go to next. Okay, next one is peak. If we already have one, or if okay, if we don't have anything, we will append but we need an allocator now. Oh, we have it on the Lexer, I guess. All right. So we're appending the next token into the peak tokens if we want to peak, if we don't have one. Otherwise, we should already have one. So we could just say peak tokens. Or I mean, yeah, if we go down here, we should have one. So we can just grab the first item there. Because either we had one from before or we appended it. Okay. Now peak slice is gonna be a little bit different. Because we're gonna get a length. And we need to know how many tokens we need to consume, or yeah, how many tokens we need to get in order to be able to fill this entire slice here. So we will do we will do, so we will take, so let's get like the difference is gonna be length minus this length. So this means that if the difference is more than 0, actually we need to convert these. Oh man, this is a bit annoying actually. We have to like, just to make sure we don't get some overflow issues here. Or wait, maybe we could just wrap around. Actually, couldn't we just do a wrapping? That would be the same thing, right? Right. Isn't that supposed to be the same thing? Okay, so if the difference is positive, that means we need to get more items. But or let's say if it's 0, we can just return. Then they are equal, so we could just return the items directly. If the difference is more than 0, we need to consume until we have enough. So then we need to for diff, and since this is an I size, we have to int cast here. But that should be fine because it's it should be positive at that point. Okay, and then we get, I don't think we need that, but we basically say append Oh, it's a function. And then this will be try self-guarded next. There we go. So we're appending in as many as we need, and then we return the items. Okay. However, otherwise diff is gonna be less than 0, which means we have enough, but we can just return a slice from 0 to length. Does the zig-like just not do any basic type checking? I keep noticing there's no warning or error whenever we forget. Okay, it does have. However, I find that whenever I type stuff, I feel it's super annoying when you get a bunch of red lines and squiggly things everywhere. So I've disabled in NeoVim. I've disabled all error reporting. That is like, if you get error diagnostics, what you have to do to see it is I press F8, and that will jump to the next error, or I can get the error list like this. But as long as I'm editing code, I don't want a bunch of errors popping up, because that it just disturbs my flow entirely. So yeah, that's why you don't see it. All right. So if we have enough, we do that. Actually, we could do this. If it's less than or equal, we should be able to just do this. And then otherwise, we will do this. Yeah. And I mean, instead of doing this, we could just do no, that's fine. I think I'm just worried about this a little bit here, but it should be fine, right? There might be something weird with the types of variables there, but I mean, the safest thing would be to like int cast as isize negative in as isize int cast. That's the safest way to do it. But I think that the wrapping will work though. Okay, well anyway, now we've got peak slice. I just want to go through everything here to see what else we need to fix here to this new, like having this new buffer thing. Let's see, deinitialize, we should just deinitialize you as well. Actually, you know what, is this allocated an arena? Yes it is. So then we actually don't need this. Okay, then we just do that. Okay. Consume if. Right. Now we could also add a convenience here, which would say that, okay, we want to expect a slice or something like that. Maybe? I don't know. Anyway, guarded next. what do you actually do? You have like active next step, max guard depth, token consumption. Right. There's like a runaway guard here. And then we have next token is Lexer next. Alright, so guard the next basically is presuming that we actually don't... We are going to call this with no regards to the buffer. So let's just go through this here again. So we've got... Actually, snapshot restore needs to be fixed now. Because we can't just restore to an old... Because the underlying pointer here could have been invalidated. So what we need to do is we need to do this. We need to have the buffer pointer, so all items is gonna be items, or actually allocated slice. This gives us the whole thing. Wait, do we actually need that though? We don't. Well, whatever. This gives us the whole thing. Yeah, the whole allocated slice. Because in the old, or actually this would be current items. Yeah. But if we restore to another stream here, this could have like an invalidated pointer in this thing here. So we need to, after we've done this, how would you do this? I guess first we could check if current items is equal to, like, if the pointer, I guess, is equal to the to this pointer, then this is the only thing we need to do. I mean, the easiest way would just be to say self peak deinitialize right, except it's not that simple, because this could point to the same this could still have the same pointer, so we're deinitializing the only pointer that's alive. So actually we do need to check this first. If it's the same, we just do this and return. Except there could be a capacity difference. Actually, well, we should check the length as well. Now, but the pointer is the same, then we deallocate the same thing. The old one could be deallocated already. And this is not trivial here. Okay, let's just go through the scenarios here one by one. So we have this and if let's do like current items and then snapshot items. Okay, actually, you know what? A more safe way to do it would be to duplicate it. So we just duplicate. We do S peaked clone. This is a clone. Cloned items. Then we do this, but this, we set this to the clone, and then we deinitialize. Well, we could deinitialize this now, actually. We'll deinitialize this. Or maybe it's up to the user to deinitialize that. No, that's fine. I'll just add a notation here. Invalidates the buffer in the snapshot. Yeah. Because basically what could happen is we create a snapshot. We're basically just copying everything over here, but this now that was fine before because we didn't have any allocated stuff in here. However, now this one, actually maybe that's not true. Like the Lexer is also part of this. It does have array lists here. Ooh. But the Lexer shouldn't actually change. I don't think. No. The Lexer shouldn't. Actually, maybe this shouldn't change either then. Now this is more complicated than I thought. Well, this is the only thing that allocates here. The context stack, right. This is a fairly new concept. It's only well, what we could do is we could initialize it with some capacity that is like the max capacity, so it acts kind of like a hard limit, because then it would never allocate again. Because really what this is only active during interpolation, like string interpolations. Hey Vivex, how's it going? It's only active during string interpolation, and it will only grow if you have a bunch of nested string interpolation expressions, which is probably not that common. So what we could do is just initialize this with the capacity at the start. We have an allocator, so we could just say, instead of setting this to empty, we can say context. Where did it, why? Context stack is equal to init capacity. And then like max context stack. I'm gonna mix convention here just to be silly, and I'll just say 100. You're never gonna have more than 100 nested string interpolations. Basically like this. Const string equals this equals another string equals, or like this, like 100 of these, you know, nests. Or I guess it would be 50 because you have one, this is one context and this is another context. This is one context, this is another context. So 50 of these is the limit here. If you reach that limit, you're doing something super weird. All right. Then you can, does this work now? No, it doesn't. Or does it? Actually, does it work now? It works. Hey, awesome. Now I can change a whole bunch of these yeah, now you can just say dot init instead. Awesome. And same here. All right. No, it's not get last or no. It's get first head. If items length is 0, return no. Otherwise, return 0. All right. Back to here. So, what else? What else? Okay, so basically now also context stack. We can do a very tiny optimization now, where every time we append here, we can assume capacity. And then we don't need to have the allocator, we don't need to try. Yeah. So this would just crash if we get over the limit, but we assume that we have capacity. And that basically, it just checks. Actually, is there a version that returns an error instead? Append bounded, maybe. Never invalidates element boundaries. If the list lacks unused capacity, returns an out of memory error. Yeah, so you could use this to check the capacity and then cause this error. Yeah, I guess that's better because then we can handle it. Like assume capacity would just crash and burn everything. But it is a tiny bit faster because you don't check the capacity. And then you don't also allocate. Here we don't allocate, but we do get an error. So that's fine. And this is just because we don't want the context stack to be allocated, like to be reallocated to somewhere else. Now it only allocates once, and that's where the, so you can copy the structure and be sure that you have the same pointer and it will not be invalidated. So basically making the lexer copyable here, as long as it's like initialized. Okay, pop is fine. That's fine. Do we have any other operations on it? No? Okay, great. Oh, these tests, man. Okay. Where is the thing? Okay. Okay. What now? So, all that. Actually, yeah, let's just double check the snapshot thing. So, that should be fine. So now, basically, we don't have to worry about the lexer. We only have to worry about this one. which we, for very simple, naive implementation here, we clone it first, the snapshot that we need to restore. We deinitialize the snapshot, the old snapshot. We also we should also deinitialize our current one. There we go. And deinitialize, basically it frees the slice, sets it to undefined. I'm not sure what actually this does. I don't think it actually does anything. It's just I think it's just a compiler heuristic thing. Not sure though. All right. So that should be good. We deinitialized all things. We restore it to a cloned version of the snapshot. That should all be good. All right, just to, you know, there's so many different scenarios here that they could have the same, you know, pointer. When do we deallocate the one? When do we allocate? Like, yeah, this is just so much easier to just clone it, because this, and also this list, it doesn't really matter that much because this list will probably not grow that much anyway. We could actually do the same thing here. We could actually do like init capacity on this one as well if we want, and we don't have to worry about this. However, that would put like a limit on the peak tokens, but the peak tokens wouldn't grow that much anyway. Well, okay, now we have it anyway, so whatever. Okay, so yeah, sometimes it's just easier to just not have a dynamic list, I guess. Okay, so now we can say peak tokens. No, we can't because we don't have it yet, but let's add it. Oh no, peak slice, that's right, peak slice. Peak slice, there we go. And we need a length of 2. Okay, and the identifier is going to be 0, and next token is 1. There we go. Now I believe that you could do this, maybe. I'm not entirely certain though. No, maybe not. This can't be the structure. Okay. Maybe it only works for like arrays. Okay, well anyway, let's do this. This should work. Okay, so we got the identifier, we got the next token. So here we're checking for like if we have an end. We should really make that into some sort of collection. Maybe, yeah, because this is more updated. This one here, wait, stage, this one. So this one is actually, this is kind of like a expression, I guess, terminator or something like that. How would you use it though? I guess we could use like an if, a function that has a switch maybe. Because you can't put a function here. You have to sort of like, maybe if we like is expression terminator, then do whatever here, and then in the switch we would know that we don't need to check these, but it would still be like an exhaustive thing. So I would rather have it in the switch, to be honest, but I'm not sure how to do that actually. Like you can have ranges, but those have to be, you know, you can have, can you actually have like ranges like this, parent to bracket? I don't know. Oh, maybe you can. But then there would have to be like adjacent in the enum. Okay, let's just make this if thing here. So we'll have a function is expression terminator. We get a token tag, and we return a bool, and we return switch on tag, and we basically just copy this, return true, else false. And if this is true, we will do whatever's in here. Otherwise, we'll do this. So what's happening here, we have if this is true and we don't have arguments, we return this identifier, otherwise we return it. So we always, if we go in here, we always return, I think. Yeah. But if it's not an terminator, we do this instead. Okay, cool. Now we can reuse this. Here. And we can check if this is a terminator. We do something else, or we do this. I see, this is like a pipeline stage. You know what? Actually, if this is a terminator, we should just return parse pipeline here. That should be the same logic, actually. So we're kind of pre-checking if this is if we just have an identifier in the terminator, just parse the pipeline, because that will automatically handle it correctly there. Man, this is gonna get so convoluted here. But otherwise, okay, now we need to handle the things. So if we have a dot, now we're talking member access here. Okay, I'm gonna refill my coffee. I'll be right back. All right. So we have a dot. This is a has to be a member access thing. So we want, what do we want to do? We want to consume those two things. Next token. So we consume the two tokens, so that now we can start reading the next expression. Basically, we want to have an identifier here. So this would be the what's this called? The accessor? Accessee? No. Accessor. We get the next token. Actually, we expect token to be an identifier, right? It could also be, no. It has to be an identifier. If you do dot, there might be other things in the future, But yeah. Okay, so now we can just return this, and the expression is gonna be member access. And of course, I have to do this because the LSP doesn't always. The LSP is like, it doesn't always work like when you have syntax errors, which makes it impossible to actually write these things. Because you write dot and then you expect to get auto-completion, but you don't. Because, hey, there's a syntax error here. Yes, I'm trying to write some kind of expression here. Yeah, so it's not like, it's not perfect, but at least it helps with other stuff. All right, so the span is gonna start with our dear identifier, and then we end with the accessor. Wait, is this not... Okay, there's something... Okay, maybe it's this part that's wrong. Object? Expression. I see. This would just be the identifier. So this would just be... this would be another expression, actually. So we have to allocate another expression. I guess we'll do object here. And then you are just that. Wait, there we go. Okay, so you are a token. You need to be an identifier. So what do we have with that? It's just a name and span. Okay. So this is basically Lexine, and then span is identifier span. There we go. And no, that's the member. No, the member is accessor. That's right. There we go. The object, though, is just an identifier, and the name is identifier Lexine, and the span is identifier span. There we go. Should really have like identifier to. Like identify token to expression helper function or something, but whatever. Oh, let's do try there. Okay, so now we actually have member expressions. Awesome. So if we now go here and do this, we get an issue. Expected identifier got string start. Parse identifier expression, parse pipeline, pipeline stage. So we're in parse pipeline stage. Hello V2 form. How's it going? Welcome. Expected identifier. Is it this one then? It's probably this one. So the stage first, yeah, it first needs an identifier and then it tries to read like arguments. And it's called from the pipeline parser. Why the AI PFP? PFP, what's the profile picture? Because why not? I was wondering if people would notice. Because it was an easy way to just generate a profile picture. Okay, and before this, we don't actually consume the identifier, that's the thing. We just peek. Maybe I need to double check here. So length is the desired length. This is the one we have in the buffer. If this is larger than the ones we have, this should be positive. So if this is negative, that means we should have this length in the buffer or more, which we're checking here. And in that case, we can, let's just like desired or no, let's see, yeah, and then we do that. Like if I run sig test, I will get like a million errors because I haven't maintained that. That's like AI produced a whole bunch of tests for the old code, and I've changed so much now that, and I haven't really done anything with that. So I'm probably gonna like just remove all the tests and start from scratch or something. And ask AI to, hey, create some tests later for me. That could be a good way to use AI, maybe, or at least explore that option. Anyway, so we're doing that. That will do this. Next, when we call next, we will actually remove things from the buffer if we have things in the buffer. Otherwise, we need to grab more. So, okay. So this is, we shouldn't be in here. We should be in here. Else we return. Let's just do this here. Remove this so this becomes a little bit clearer here. Does AI have good support for Zig? It does work pretty well, although it is using like an older version of Zig. So it's not using like the newest version, which has had major changes in some areas. So you have to sometimes you have to adapt to the new version if you're using that. So it's not great like for that. I had AI generate a bunch of code and I had to go in and manually change array lists and what else? Like the standard IO interface, which will change again probably in the next version. So, but I am impressed at how good it actually managed to generate the code though, like for the old version. I didn't assume that it would gonna be that good for the reasons that you're stating there, that the language is not popular yet, and yeah, there's not much there to learn from. Yeah, so yeah, I was very surprised at how much it actually could generate. So that's very interesting. Maybe the AI has like some kind of common like programming knowledge that applies to all. Like it has some sort of more fundamental logical knowledge or something. I don't know. Although that would require maybe more resources. I have no idea. I have no idea how it works. The only AI I made was like this sort of starter kit where you take the numbers that are 28 by 28 pixels, black and white numbers, and you write an AI that can learn how to differentiate the numbers. That's the only AI I made. So I don't know how this works. Like that AI is like I don't remember even what it's called. Like it's a very static neural network. But the AIs, like the learning AIs they have today are like way more complicated. And I don't know how it works. Anyway, what is the issue? What is the issue? Because we shouldn't be consuming the identifier though. That's the whole thing here. Like if we say, let's say we have like so peaked first, peak token, dot tag, and then we do the same afterwards. Now that should be the same. So yeah. Oh, wait, there's an error somewhere. function will not. Okay, so we have an. Oh, I see. At the end here, we're not returning anything. So what if we... Wait, what is this? Shouldn't it be this? And then we should probably just do this then. If this is more, then we do this. So if we need more, we will, yeah, so we don't need to know if it goes below 0. We don't actually need to know that. So actually this could just be this. If it goes below 0, it's just gonna be 0, and then we can just do this. If it goes above 0, we need to know how many we need to get, and now we don't need to intcast either. There we go. Okay, yeah, that's a lot easier on the eye there. Okay. Hey, there we go. Sorry if I screamed there. So we... Okay, and then we got this debug thing. Let's remove that. Alright. So we can see here, actually, let's change this a little bit. Let's do like... wait, how do you do this? I'll do this first. I'll remove you. I'll do terminal here. Do this. And this. Okay, there we go. Alright, so here we have the AST for the left file, which is going to be, first we have let declaration, or I should rename this into const actually. How do we have so many references to this? This is a binding actually. Okay, we have a bunch of tests. Then we have this. All right. There we go. Anyway. Now we have binding declaration. It's not mutable. We're binding lib to an import from test to lib. Then we have an expression. Which is the a pipeline. It's a command. It starts with echo, and the first argument is a text string literal here. First segment is an empty string. We should really get rid of those. And then we have an interpolation, and here we have a member expression, which is not yet implemented for printing. So we could do that. Let's search for printing not implemented. Yeah, I guess this is fine. Member. I'll just copy that. Member. Or let's just do print. Actually, the object is its own expression. Well, right now it's only an identifier, so print. Statement. Expression. Render expression AST. Okay. Script path. No, that was okay. Yeah, expression level +1. I don't think we need the indentation there. The expression is going to be member expression.object, and then we'll do that indent and I guess or print dot what is it? Member expression identifier name. Okay. Let's try that again. Okay. Except we get like a double thing there. But it does work. Okay. So let's remove that. There we go. Alright, so we can see now it's got a member there. Okay, so what's left is to actually execute, like do the execution part. So we've done the, well, the tokenizer was all around. We've done the parsing into AST. Now we need to do the execution part. So if we run this, this should just fail. Yes, unsupported expression. So we need to support the member expression. So let's go to, I believe it's evaluator. And do we have like member in here? No, we don't. So we have like eval execute statement, execute expression, and all these different things. Not sure what the, there's no difference between execute expression and evaluate expression. This is AI generated. A lot of it, like the foundation, everything here is AI generated, and I just added to the conventions here. for what was missing. All right, so here we do like member try set evaluate member expression. All right, so let's go here. I will copy that. Member. All right. So what do we need to do? I think we need to evaluate the first expression, which will be the object. Scopes. What the hell? Well, I guess we'll put the scopes here. Okay. So scopes, and then this is going to be member.object. All right, now we get a value out. Now, in terms of this value, only certain values, I guess, should be able to have members. So basically, if the value is like, I don't know, a boolean, maybe you shouldn't be able to use member access on it. And that should result in some kind of failure here. But let's do a switch on the on the object. And we have all these different types. Now void, of course, you shouldn't be able to do anything with that. So this should be some sort of error. Let's just do like return, I guess. No, wait. No, yeah, return. Okay, I'll just do... Actually, you know what? Let's just do that for now. So what kind of error do we want? Unsupported statement, unsupported expression maybe? Unsupported binding pattern? Unsupported member access maybe? Give you enough context of what's going on. Hello Nub Gaming, how's it going? I'm doing great. How are you? Currently working on member access here. Okay, void will do that. And booleans, integers, floats, strings. String will probably be the best candidate maybe out of all of those to have member access maybe. We'll see. But that's fine. Then we have process handle. Now process handle should support member access. And we actually do have another place where member expressions are actually handled, which should be somewhere here. So here this is kind of like the old code where where the AI basically did a bunch of stuff like wrong. It made super specific things for when I asked. I wanted more like general things, but it made like super specific things. Basically here you can see that this is the parser, right? And it produces some kind of module import member binding. So it's not just a member binding or just a member access. It's specific to module imports, which was crazy to me. So that's why I decided, hey AI, you're fired. Now it's probably because of how I communicated with it. I should have looked at more at the code and seen before it started to do all this crap. But what is member access? So member access is just this lib.name. That's member access. You're accessing some member of this object here. So this would access, so this is lib, import librn, here's librn here. We have a name declaration here. And that should be what you're trying to access here. So that's the idea. But when I'm looking at this is actually not execution, this is actually module import member expression. Like this is just parsing. You can see here, it actually skip white space. So this actually worked directly with the source. It didn't even tokenize the stuff. It just worked directly with the source. And then it produced this part. So I'm gonna search for this and look at where this could be used. So didn't we actually, so we never had execution code for this? Maybe not. All right. Okay, so we never actually had the execution code for it. Wait, what is happening here? Okay, so we can't actually check that. But no, wait, I wanted to check like process handle actually, because I know that was possible before. You could do like dot standard out and it would work. But anyway, let's do it manually, I guess. Process handle. Let's just call it P, whatever. Right. So, what do we have? We have a whole bunch of stuff here. I've never actually worked with this thing here before, so it's gonna be interesting to see. It's kind of like getting into a project that was, you know, recently started, except it's like AI that built everything. Yeah, you're trying to access a process handle. Right. So now it depends on what you want to access. So basically, we should only allow kind of three things. So we should do like if the member that you're trying to access, if this is equal to standard out, then we should return I don't know, man. Just a stand, like we would probably want to return some kind of representation of it. But I guess we just do the bytes for now. Except this needs to be a value, so we have to do like, I guess like a string maybe. Yeah. What's the issue? Oh, there we go. AI makes green field go brown real fast. Yeah. But that's also a little bit like I love the feeling of starting a new project. Like that's such a nice feeling when you're starting a new project, trying out a new idea, and at the start you have like the most productivity and you're building all these things, but then after a while things start to slow down and it gets more and more, it takes longer and longer to do things, you know. But the startup is always like, it just feels so nice because everything like seems to fall in place and it seems to you're like super productive. And then, but now when I started this project with an AI, well, I have started projects like this before, so I thought that, hey, why wouldn't I just use AI to just make me a scaffolding basically, or just use AI throughout to actually create the language as far as I can and then take over basically, which is pretty much what I've been doing now. But it does take away a little bit on the whole like new project feel to it. But then again, making a language is not, you know, a trivial task. So it's like if you're starting a new project and you want to create a new language, there's so many, especially if you want to have like LSP, type checker, everything in there, and you're doing everything basically from scratch, then there's so many things you have to like put in place before you can actually get something out of it, I guess. So I don't know, it's pros and cons, I guess. And also, you don't know if the AI is actually going to lay out the project for you the way you want it to be, which obviously didn't happen here. So I had to change a whole bunch of stuff. But it did show me a few things that, especially for like the script execution part, which I've never sort of done at this level before. So it could be very helpful to, you know, get through some of the issues that you can get stuck at, and just ask it like, hey, how would you solve this problem, or something like that. So that is very helpful, and I'm very grateful that we have that now. I'm not sure if it would have been able to solve the general protection fault thing, but I never tried, so I solved it myself. But yeah, I went like AI overload for a while, but now I've kind of moved back, unless I can do some parallel, like work in parallel or something. All right, so let's see. If we have standard up, we do that. Otherwise, we will check if we have standard stir. We will return string standard . Otherwise, the only thing left would be I guess exit code or status code. I'm not sure exactly what it would be called, but this would be I mean, I guess it's kind of like a byte, but I don't think we have that. Status, exit code. Okay, so there's actually more information here, maybe. Maybe we don't have an exit code, I guess. I'm just gonna do this. I'm just gonna force it to be there. And then if you try to use it, it's just gonna fail. Alright, so let's do scope. Right, so this is the thing that we actually have. Now, the scope means that it's a module, it's another module that you're referring to, which has its own scope with everything. And so we will look up this name, which is member name. So we'll get a nullable. If we don't get anything, what happens then? I guess it's like an error. Return. Actually, let's get rid of this return here. All right, return error. I guess like member not found or something like that. Pretty descriptive. Alright, but if we have it, we will, what can we do here? We have mutable value. Yeah, we just return the value, I guess. Yeah. No. How many errors do I get if I change this? Oh, also that doesn't exist. It's like an, let's just do an integer. Yeah, we get a whole bunch of these. I'm not sure why they would be mutable. Well, okay. Another way to do it, though, oops, is if we change this back, and we just duplicate it. Do we have like an let's just duplicate it. But I'm not sure how this allocator works. Like, do we have a deinitialize function? Okay, maybe the user of the value will deinitialize it. Yeah, this frees it. So you should actually duplicate it. Okay, that's good. Alright, so this means this whole thing, it's just because we have this huge error type, like error union type or error set. It just means that we don't, there's a one of these cases where we don't actually return anything, which is kind of weird because this should be an exhaustive switch, which everything returns. Oh, it doesn't return here. Oh yeah, if we get here, this should be an error. So this should actually be like member not found. Yeah. Okay. There we go. All right. Let's see if this works now. No? Well, it kind of works. Well, it does work actually. Except we get a general protection exception as well. Hey, that's on the house. But yeah, it does work. Cool. So why do we get this here? We're trying to free the standard out. Okay. Is something happening when I call this? Not really. Should I clone the value here? I mean, yeah, if it's a string. But this captures standard out though. I should maybe clone this value. Yeah, I should definitely clone this value. Okay. Now you I don't need to clone because you're just a silly byte. Oops. Oops, whoops, whoops. There we go. Hey! It works! Wow. Okay. Okay, I'm not sure why we get like new lines here. Maybe I should look that up because that's a little bit annoying. But yeah, the import statement executes the library. And we expose this here. And we can access it over here. Awesome. So now I want to fix this new line problem here. I have no idea why we have it. What if we change to printf? Will that work? Okay, that gets rid of the... Okay, so you should only use printf. Why is that happening? Okay, this might be some weird special like handling from bash. Like if you do the same thing in bash, you don't get these extra new lines. Is it because when... Okay, this could be it. Like, name is echo. So, actually, we are capturing, like, the standard out. So, name is actually including the new line, maybe. So, when we interpolate it like this, we get an extra new line in there, perhaps. And then this one, I'm not sure how this echo will handle that. We get a string with a new line in it. But then it probably... Yeah, okay, so let's do this then. Surname is echo... Or I mean, let's do like... yeah, let's do surname echo lib.rn. Full name is name surname. So now will that get like split up? Hello from full name. Yes. So I guess bash, when you do this, it removes like the new line at the end. Perhaps. And you know, I've been looking into bash a little bit recently, and there is so many special kind of things you can do to change the behavior when running bash commands. So I will not be surprised if there's and also probably to echo you could put flags and stuff, but probably there's some kind of flag you can set in bash or something that makes it so that it keeps the new lines or something. I don't know. Okay, so then we know what the problem is. Now, how would we solve it? Would we want to mimic the bash behavior? Or maybe solve it in a different way? That's gonna be a lot of these. A lot of like design decisions. It's gonna be like, okay, let's say that we look at bash and say, okay, well, what are some of the useful stuff that you can do in bash? We want to move this here, but we want a more consistent like syntax basically, and maybe also a more well, I don't know. We'll see. We'll figure it out. It's probably gonna change a lot, like in the start here. Not sure if printf behave better. No, I don't know. I mean, it depends on what you want to do. Like, do you want to have a new line at the end or not? Like, if I do printf, like if we change this to printf, it's kind of, if I change that to printf, there's no. Okay, I see. It didn't actually add a new line there. So printf doesn't add a new line, echo does add a new line. I mean, to be honest, I would actually want the actual output. I wouldn't want to have a special, like, these kind of data massages that like automatically is happening behind the scenes. I don't know. That's because as soon as you want to use something, like you make a program, you have to make it compatible with that or something. Like, I don't know. There's just something about automatically doing those kind of things. Most programs would end with a new line. You won't want to handle that. I mean, there's a purpose of also just having a program that prints without a new line. But yeah, okay. Well, it all depends on what you want to do. And I've been contemplating like how would we solve it in that case? Like, would we have, you know, in bash you have things like you can set I don't know, shell option, you have like IFS, you have there's so many different like settings and options and stuff you can do to change the behavior of things. But it just feels so, it feels like everything is like in an island of its own, and then you have to figure out how it's gonna like work together or something. I don't know. I'm not a bash expert, as you can tell. So it's kind of funny that I'm trying to make a replacement without even knowing a lot about bash. I just know that I look at the syntax and it's like I'm trying to write the if statements and the for loops and everything has a different special syntax. The match cases stuff. Yeah, it's just everything is different. Every time you do a thing, it has a special syntax. And I don't want to have that in my head. I don't want to keep all that in my head. I would rather have like a normal, consistent system and work within that instead of having to remember all these special syntax things. There's probably like, you know, libraries you can look up and or, you know, documentation. Like every time I search for bash documentation, you get like this old web page that you need to read through a couple of pages to get your answer or something. I don't know. Okay, enough about that. Let's just continue here, because even though this might not be like a perfect replacement or something, it's just a fun activity to build this language here. It might not, you know, get to anything like useful, but it could be useful for me though. I'm not gonna copy bash straight away, like all the features of it. That's gonna be a lot of stuff. I'm just gonna build what I need, and then if other people wanna like contribute, that's fine. But yeah. Okay. Anyway, rant over. What do we want to do now? So I'm just gonna ignore this new line thing for now, and we'll probably add something like, you know, string manipulation. I'm not sure how that will be. No, we don't need echo there. It's just to show that actually name is not really a string. It's actually a process handle. But then when you interpolate it like this, it will grab out standard out and put it there. So it's just to show that you can actually do this, you know, without much issues. And you can also do like standard out now, I hope. No, you can't. Wait, you probably can, but there's like leaked memory here. Oh. Memory address leaked. Declare string binding. Sync identifier binding. Sync context for let executor execute. Okay, so there's some leaks issues here, but if we go up here and we can see that it still works. So it's basically just to show that you have when you do this, you have a process handle and it has a bunch of information. You can do standard out, you can do standard error, you can do, you know, exit code or status or a bunch of stuff there. What is this? Okay, that's weird. That's the LSP freaking out. All right. Anyway. Yeah. So that should still that should still work, but we get like memory usage. Maybe have magic by default. The user can use standard out if needed. Yeah, that's how it works now. So you can do this. This would automatically coerce it into a string using standard out, but you can do this explicitly if you want. You can also use standard error if you want, but this, if you just use it this, the default, I guess, behavior is to use standard out. It's just so that you don't have to, you do this and you're like, okay, well, I get the exit code, I have to write, what is it, like this or this or something, I don't remember, or this, I don't remember. It's so, you know, there's so much magic going on in bash that I want to unravel. Okay, I don't want to bash on bash too much. See what I did there? Okay. Man. Okay, I need more coffee here. I'll be right back. All right. Okay, let's continue. So, all right. Okay, why did we get a leak? We're duplicating this. Is it because we need to handle this process? Like, do we need to de-initialize it or something? I have no idea. Materialize string. Alright, this is the coercion here. You can see here, if we have a process handle, we actually just take the standard out bytes. But the thing that's missing in my language right now also with processes is streaming. There's no streaming in the pipes right now. And I need to fix that as well. It executes like the first stage fully. It waits for it to exit. Then it sends everything at once to the next process and so on. That's how the AI did it. So I'm blaming AI for that. But evaluate pipeline. Yeah, here's what it happens actually. We got all the specs here. Owned strings, okay. And we're going through all the stages, looking at some stuff. Doing that. So now the let me look at this here. We're actually deinitializing the value after doing that. But the problem there though is like, okay, but can you actually not reuse the same thing multiple times then? Like if you have a process handle, next time you wanna like evaluate the expression, it's gonna be deinitialized. How is that? How would that work? That's well, I guess it's running this, and then the result is put here. But that's a process handle. Next time we're using it here, this gets deinitialized, so we can't actually use name again. So if you try to use name again, this will break now. Let me also, like if I do this, does it not break? No, we still have leaks. Why? Okay, let's go back to this. Okay, this doesn't produce leaks. But if I want to use this again, Will this break now? No. What? Wait, how does that work? Okay, I just need to BRB 1 second here. All right. Where is this call from? Render. Oh, so this is called here, I guess. Okay. Render command part. Render command part. Oh, I see. So it's to know which name we need to have. So arg v. Yeah, okay, and then it does all that. Okay, so it's rendering the command part. And at that point, we materialize the process handle. Oh, but it's duplicated here. But it's deinitialized here. Huh? So would that mean if we use what about a string? What about an interpolated string though? Where is that handled? Here? Track string, render string literal, interpolation, evaluates, material string. Yeah, so it does the same thing. Because we're creating a new value from this, I guess. If it's a pipeline, it evaluates it. If it's an identifier, we clone it. I see. Okay. So there's a pattern here. I see. Okay. So we clone it. If it's a process handle, we clone it. Okay. That's why it works. So you have to think about that, especially with the scope here. Because we don't clone the scope. And I don't think we should. The scope. Yeah, I'm not sure actually. I'll make a to-do here. Investigate This could be an AI thing. Go through all to-dos and do them. Investigate if we need to clone this. And a hint would be hint. Every time we use a value in the executor or evaluator, evaluator, we seem to clone it and deinitialize. So if we deinitialize a scope, nothing happens. Okay, cool. Because the scopes should be deinitialized later. The scopes are kind of like global, because each module, yeah, it makes sense. They are like globals. Like you don't have your local version of a module. It's global. I wonder actually how that works in Zig. Like, let's say you have pub var x and you import it. So let's say we're in another file and we like import this. And we set this to 3. Would that also affect the other places, like you have this? You know? Will this be different now? Okay, whatever. We'll figure it out when we get there. All right. Okay, so what else could be the issue? So it's basically, now it's just, even if we use a string, a normal string, we get a leak. Let's simplify this a little bit. And I'll get rid of this. I'll do like, we'll just echo hello. That works. Let's bind hello. And we'll echo that. That works. What if... Huh. Okay, what if we do this? We simplify this a little bit. And then we just say name equals lib. Okay, that's fine because we're not importing it, but let's import it. There we go, there's our leak. So this is enough to get a leak. We just have a name. As long as it's not a process, or as long as it's like a normal, like just a string, it leaks. What if we use it? It still leaks. I guess that makes sense. Okay. Where is the leak from? Script context Dupe name owned. Here, declare string binding. All right. Now this part I don't know that much about. I guess it's like a way to keep all the strings in check. So name and value. I mean, wouldn't this just be a part of the scope, I would assume? Find binding index. Why would we need this? Why couldn't we just use like a scope? Maybe it's because the names, like, they need to be allocated and we need to put them in a table so we don't lose track of the strings. All right, so let's learn how this works here. So we got a bunch of bindings, and what are we doing with those? Function bindings, value. So that is the runtime value, I think. No, it's not. This is a different value. Oh man. What is happening here? I think this might have to do with the old stuff, maybe? Yeah, this is out of scope. This is not the evaluator. This is the executor. And it does this part. What if we just don't do this? Will this break something? Okay. Problem solved. Yeah, I think this is just part of like the old thing, and I just didn't realize that this needed to be removed. So yeah, okay, cool. Now let's go ahead and clean that up properly here. So this is actually okay, we still have these things, but maybe these are not actually used now. Yeah, this is not used now, and this is, yeah. All right. Render binding error. This is not used either. Cool. And so this one, where is this used now? Here. Okay, it's used in a bunch of tests. I'm just gonna delete this test. I'm gonna delete all this crap. Yeah, this is like old stuff. Module invocations. I'm just gonna delete all this. if I for some reason need to have a reference to this, I could just go back in Git history and take this back. Holy shit, there's a lot of these. What is this? Parse module functions. This is not used. Well, okay. Ensure import. Yeah, this is not used. I'm gonna remove this. This is not used. Anything dealing with module registry is gone. This one, not sure, but this one is done. Yeah, this is what the AI was thinking, like, oh, you need like a special parser and special like thing for all this. Like, all this is so unnecessary. All right, nice to get rid of this. Module expression error, expression parser, like this. I just delete this. It had like a special parser for yeah, look at this crap here. Parse module invocation. Let's delete this. Yeah, all this is like special just for the module import. What is this? Parse left binding with options. What? I think all of this we just remove. Yeah, this is not used. This is not used. Evaluate operand. Evaluate expression. Handle ensure call. Not used. Man, there's so much code in here, man. Holy moly. Compute function skip depth. Look at all these this AI generated code. Let command needs more lines. Control flow needs more lines. Sanitize. Snippet. Could probably just remove this entire file, to be honest. Yeah, this. No. Command starts with if. Okay, you only refer to yourself. Like when I was telling AI to do this, I was like, holy shit, I got all these features in. Let's go and look at the code. Oh. Because at some point it's like, yeah, I can't do this, but I can't, like I was like putting more and more features into it, and that's what you see here, what I'm like tearing down right now. And then I was saying like, okay, well now I want this feature. All of a sudden the AI said, I can't do this. And I'm like, wait, but this should be doable. And it's like, no, I can't do this. Okay. Why? And it's like, well, I need to do this and this and this and this and this and this in order to do this. And it's like, okay, well, do this then. And it's like, no, I can't do it. Okay. And then I started to look at the code. And it was just this whole mess. Yeah, so this should be used like everywhere. I think I could just basically remove everything. Yeah. Parse string literal. Type expression. I just want to make sure I'm not removing anything that I actually need. But I don't think I actually don't know. Yeah, zig-like config we actually use, so I don't want to remove that. This one we can remove. Record AST snippet. This one is used, so there we go. This should all be used. Okay. This one is not used. Yeah. So much code, man, to waste. It's nice. It is nice to remove code. You know, that's usually a nice feeling. But when it's code that you didn't write, and it's like, but you told AI to write, and then it's like, okay, well now you have to redo everything. It's not as nice, but yeah, whatever. All that wasted effort. What is this function? Run script. Okay, this is definitely used, so I shouldn't do anything there. Expose string script method. Oh, I have no idea what this is. Brace, balance, delta. Quote mode. Extract return command. Yeah. Oh. Okay, don't tell me Vim or NeoVim mismatched some of these. Parse command line. That is definitely used. Yeah. Is comment start? That is not used. Oh man. How many lines of code is there? 1400? Binding provider. Yeah, this isn't used now, so we can just remove that. Parse. This one we can just remove. This one. This one. Alright. Interpreter state. No. I don't. Yeah, this is not used. AST snippet. Wait. Oh man. Parse result. Parse command. Right. We need that. Arg equal sure. Duplicate slice. Why do we have this? We could just use allocator dupe. What the hell? Oh man, okay. Yeah, okay. So it's only for like U8s. So it should be like allocator do U8. Man. God damn it. Binding expression, goodbye. Object literal, goodbye. Ensure call, goodbye. Goodbye, goodbye. Goodbye. Type expression parser. Could be pretty cool to look at, but whatever. I'm just gonna redo this. Like the type expression parser, yeah, it made its own parser for type expression. Like, what am I doing? I'm removing like a bunch of AI slop. Okay. We're down to 806. How many lines of code did we remove? Render, yeah, that should be good. Render command. Print span inline, yeah. Interpolation error. Pipeline. Do we use this? Yeah, apparently. Okay. Maybe that's it. Not sure. Usage error. Finalize list. Parse. All right. Is this used? Yes. Expression value. This is not used, so you are not used. Quote mode is not used. You are used. You are used. Alright. Colors are used. There we go. Oh yeah, that's right. Okay. Nice. Now, let's get rid of things here. You, we don't need. Don't need you, don't need you. Wait, why is this not matching What the hell? Oh, parser error, parse error. Okay. Wait. Oh, okay, whatever. Okay, that's the only one. There we go. I think we cleaned up this file now. 747. Nice. How can you see number of lines? So we removed like 1700 lines of code. Cool. Now we don't get to look at those anymore. Alright, we have some issues. Oh no. Ensure executable dir on path. Path has entry. Oh my god. Oh. Wait. How do I do? Okay, let's just do this. There we go. All right. No, okay, this one we can actually just remove. Because, yeah. There we go. Okay. Still works. Good. Good. Very good. All right. What if we use printf? It's gonna be on one line. There we go. Okay, everything still works as it should. Nice. Okay, let's get this back here now. Awesome. Yes! Sorry. Oh my god, what the hell? I pressed some weird combination of keys and Windows freaked out. Okay. Alright, what about now we can use standard out? Ah, okay, now we get a leak. Let's look at this here. What is this leak here? So we clone, capture, standard out. There, okay, so this clone is not handled. Alright, let's look at this. Interpreter, value, no. Probably here, evaluate the 216. Evaluate identifier. So we're looking up the name. Okay, I see. So basically, right, we're using, well, we're looking if the identifier exists, and then we're returning the value, but we're also cloning it. So every time we use this, we need to make sure that we're yeah, okay, we're cloning the value of the identifier, right? Now where do we call this from? Evaluate expression. And where do we call that from? Evaluate member expression, right? So is it this one? Object, maybe? Yeah. So we actually need to make sure to deinitialize this then. What? Oh. Okay, I guess we need to make it a var. There we go. There we go. Awesome. Okay, so basically what's happening, we import lib. It's doing all these echoes and stuff. Actually, let's change that out to a string. Does it still work? Yeah. All right. So, so there is a couple of different, like, I guess you could say, like, ways to deal with strings here. You can get a string from a command. You can just assign to a string. You can have a command with interpolated stuff, and here you would you can actually, because name is set to this command, that means that name is a process handle. So here we're actually, you can access standard out or standard error or exit code or whatever on it. Here we just interpolate this string here. Here we're interpolating this process, but we don't specify what happens when you convert basically a process to a string. Well, we just take the default is just to take the standard out from it. And then here we just do some commands, which will actually show on the terminal when we import here. And then also we can echo libname. Now, crucially, if we import lib again, oh no, lib again, you know, you can do it how many times you want. And we can echo lib again dot name as well. It works. And you can see here that these hellos only happens once. These hellos here, they only happen once. They only happen when you import it for the first time. Then next time it won't happen again. And all the values in here will be like set the first time you run. Then it's gonna set all the values and stuff. If you import it again, now we don't run it again. So that could be, you know, they could trip you up if you want to do, if you want to import it like multiple times in the same like runic process, I guess, and also have it execute like multiple times, or have it depend on like outside scope. But the idea is that you wouldn't actually depend on outside scope here. The only thing that's gonna be passed from the parent to this is gonna be the environment maps. However, what you would do is when you want to like reuse functionality, you would create a function instead. So you would create a function where you would say the thing you want to say or do what you want to do. So that is how, and then you could just, then here you would do, you know, lib hello, or just lib hello like that, like execute it as a command there. That is the idea. So you would probably not have echo set, but you could. So I basically looked at how Python did it, because Python you can do the same thing. And Python does like this. So it basically executes everything the first time. You import a second time, it won't execute everything, but it will keep all the values and stuff, and you can reuse them here. The function, and then you can just, you know, access the functions and call them. However, functions doesn't actually work yet, so I need to fix that. So this would actually just, yeah, fail at parsing here. And yeah, I think next step is I wanna, because the LSP stopped working for some reason, so I'm going to try and fix that. Yeah. So cool, but now we've got member access. So actually, maybe I should push this here. Whoops. All right, let's do like added member access. There we go. All right. Okay. Now, LSP. Why is the LSP not working? Let's go and look at I guess maybe the parser. Man, I should have done this yesterday because I had everything fresh in my mind at that point. Because we had some issues regarding the document store and everything. Also, what is all this crap here? Oh, we're like reading in if we didn't find the document, I guess. Okay, let's just start here. Let's just start at trying to run the LSP. And I'll look at the logs. Okay, there's no issues yet. And if I do something here, it still works. Or yeah, it still works, okay, but it doesn't send any diagnostics, is what's the weird thing. And it did crash yesterday, but I don't know exactly what happened. So also here, like, okay, we received a message. No, where's the did change? What? Okay, let's do one. Let's do that. Why is it not working? You know what? Let's just restart. Okay, we opened it. Here, did open, I think. Yeah. And then we change something. Oh, now we get diagnostics. Okay, I'm not sure what happened there. Let's try and... Okay, there we go. Now we got a crash. So why did we get a crash now? I have to look at these lovely logs again. So we got a did change, which probably is the starting point of this error. New document text. So it tries to like, it's reporting that, okay, I see what you did there basically. And then we get a seg fault. Symbols 35. All right. Is it LSP symbols 35 collect symbols? So it get a seg fault here on script statements. Okay. From here, script equals to parse file. This returns a script. Parse script, otherwise return null. Right, parse script. Yeah, this is just a parser. Could it be some allocation issues? Let's look at how the parser is allocated. Self parser, what are we? We are a document. Well, this is just allocated using this, so maybe... No, that's right. It's allocated somewhere. It has to be initialized here with an allocator. Okay. But what is this allocator? It's the document store. Aha, I see. I think I know what the issue is. It's the same issue, I think, as the other place. Yeah. Because it's like we're using an arena. This allocator... Wait. Man, this goes back a long way. Maybe not actually. No, that's just a normal allocator. Okay. Because the issue we had before with this, but this was a different version. This was for the script runner or and parser. This is the LSP. It has a little bit slightly different setup. But the issue there was that we used basically an arena allocator for the document store. But then the document store included parsers that were also allocated with the arena allocator. However, each parser also has its own arena allocator. And there was some issues with that, where one allocator basically overwrote someone the others allocator stuff, and yeah, it didn't work. So, but this allocator is just a normal allocator. Yeah. And when we create a new document, we use this like GPA to initialize the document. And the document has a parser, which also is initialized. Well, it's initialized actually over here. Right, it's like if we have a parser, we initialize it, otherwise we create a new parser with this allocator, and then this one actually has an arena here, and so when you deinitialize the parser, it just deinitializes the arena, which releases everything that was ever allocated to this arena. But the problem before was that if you used an allocator that came from another arena, then for some reason that became an issue. Apparently, I'm not sure if that was the actual issue or if there was something else, but we did some stuff and solved that issue. Now we have another issue here, and I'm trying to find out why this is an issue. So we have this initialized. So it's also important to see that when this is called, we deinitialize the previous arena. So the previous kind of result is invalidated as well. And here we're trying to, but we're trying to rebuild again here, I think. Did change. Rebuild symbols. So we initialize the previous one, we initialize a new one. I might change how this parser works, because it doesn't really need to be able to get the documents like this. But yeah, that's for another refactoring here. I put this here just so that we could it could get any document that it wanted, but then also publish cached AST to any document, and also get the source so it could actually parse the thing. But we don't really need it to have that kind of freedom. We can just create one parser for each document and then use it. So that's why this looks a bit weird here. I had some refactoring being done there for that. And then it goes in here and parses the file. Okay, maybe, wait, you know what? No, because we're deinitializing the old parser and then we're creating a new parser here. So at this point, this document should have the new parser set to it. Because I was thinking maybe it kept the old parser or something. So at this point, we parse the script. It tries to get the cached AST, but that shouldn't exist because the parser doesn't exist. Wait, actually, hang on. The cached AST, that should be thrown away at this point. Aha, maybe that's the issue. You see here, we have the AST. If this is still around, when the parser gets the initialized, this might get invalidated as well. So we need to, these need to like live together basically. Also, why are we not deinitializing like the parser here? All right. Anyway, so here, so actually here we also need to set AST to null. You don't have like the initialize or anything, no. Yeah, that's right. So when we parse this file, we return a bunch of statements in the script. Now these statements are returned from this and then just put here. So we don't really you know, it's not supposed to be detached from the parser. It's actually like part of the parser, you could say, like memory wise, like allocator wise. This here is allocated in here, which is gonna use the arena allocator. I'm pretty sure, yeah, we're copying to arena. So it's in the parser arena. So this script is attached to this memory wise. This AST is also, why are we not like caching it? Where are we setting? Where do we set this? Oh yeah, in the publish. That's right, in the publish. So we need to reset it here. I think that's the issue. All right, let's try that. It's a little bit, you know, if you're not smart about your allocator stuff, you can get into hairy situations like this. And yeah, I'm not really super used to that. Let me restart. And this seems to be some kind of racing condition as well, so I'm not sure how to trigger it, but yeah, now it seems to work. Okay, cool. All right. Nice. Okay. That was good. I need to fix the have a better pattern there for allocation stuff, but yeah. All right, now what do we want to do? So I think maybe should we start on functions? Okay, let's also do like to do. This is done. So imports are like, they are like fully done now, I think. And this one is done as well. That's really cool. Okay, next up I'm gonna add functions. So what do we need for functions? Oops. So we have the Lexer part is done, so we have the tokens. The AST, actually, you know what, that's not true actually, because it does fail. It fails on like the Lexer part actually. Or wait, no it doesn't. It fails on the parser part, yeah. So we do have the Lexer for it, maybe, we'll see. But it's like the AST, we need to build the AST for the function, and then we need to executor. Yeah, that's gonna be the hairiest part of this, I think. It's also, I thought about like variables, like do we want to have some kind of pass by reference sometimes, like you have like the process handles, for example. And then we have like structs and everything, like maybe we want some kind of syntax for that. I don't know, we'll see. I think for now I'm just gonna pass everything by value, but yeah, let's see. Okay, so let's start on this then, the AST. So we'll go to our dear parser. I should clean up some of those documents as well. All right, so what do we need to do? We need to go to like parse, I guess, statement. And here we have a bunch of different things. We have let, we have expression. So, I mean, technically, a function could probably be thought of as an expression. However, this type should really not be an expression, like, you know, because, you know, you're typing the name twice. So it will make more sense if you could do this. Also, I do like it when a language has like shorthand syntax for a function. So I would like this syntax, or even like type inference, you know. I like this syntax. So I'm probably gonna have this syntax as well, or even this, you know. This is what I want to aim for. But for now, we're gonna start with this. Okay. So you're gonna be able to like declare functions both like this, but also like the shorthand like this, because I do like it when you can do that. Yeah. All right. How do we want to start with this? So I think we parse maybe a let here. Let's also maybe parse I guess we'll keep the same maybe function, and this would be a function declaration, and we will peek the next token, and this needs to be a function. There we go. And here we actually do the parsing here. Maybe this is a pattern that we wanna employ like in a function, but yeah. Let's just do this for now. And we don't have any function parser, so we need to make one here. Parse error, and we get a function declaration out. All right. Now, how do we do this? Well, we are going to first we will expect tag function. So first we consume that because that's not consumed here. We just peek and then we say, okay, if it's a function token, then we actually parse the function. If it's not, then we return null, so we can try something else. Here we actually do the parsing of the function, so we need to consume this tag or this token here. This will consume it, I'm pretty sure. Consumes the next token and yeah, I'm just gonna say it consumes the next token because the rest of the information is pretty self-explanatory. All right. What comes after that? I'm just looking at this here. So we have an identifier. So that is very strict. We only expect an identifier here. Okay. What then? We need to have parentheses. So we are going to, but we don't care about the content there, but we are expecting a left parentheses. And let's not think about the arguments for now. So I'm just gonna say right parentheses, but we can do in here we will have or I guess parameters is the technical term for a function definition. Okay, and then we have the return type. What should I use? Should I use snake case or camel case this time? Let's do camel case because I saw snake case in the suggestions. So you have to mix it up a little bit. All right, and this will be actually this will be like a parse type expression, but we don't have that, so we have to make it actually. Maybe it's like maybe type expression, to be fair. And if we don't have it, it's gonna get inferred, I guess, somehow. But we don't really have support for types anyway, so but I'll just make this function here so that the syntax works, but it won't really do anything. And this would be like a type expression or a maybe. So actually, you know what? I'm just gonna return null, and we will peek at the next one. So if actually we do have a consume if, wait, was that only on the stream? Consume if. Okay, I guess it's fine to have the stream referenced here directly because this is very temporary here. But I'm gonna consume if it's an identifier, I'm going to consume it and return null. So that way we just skip past this type, you know, annotation basically, and continue on. So here we can just say this. So to do types basically. Yeah, and then we have the left bracket or braces, the left brace, right brace. So this would be try self expect token tag left brace, and we have right brace, and in here we want to parse a bunch of statements. So actually, you know what? This would kind of be, I think we have like parse block. Yeah. Which includes, it includes the like the braces here. So we should just parse a block here. We don't need the braces explicitly. We just parse a block. And we get a block out. And the block includes like a bunch of statements. And actually, I happen to know that the function declaration has a special kind of block. It has a function body. The function body has a block, but also an expression. I don't actually know what the purpose of this expression is. I'm not sure what this is referring to. So I'm just gonna, I guess I'm just gonna ignore it for now. Like, you know, maybe I was thinking like maybe it's like the last expression. Actually, what the hell? This is a union enum. Oh, okay. So it could either be a block or an expression. I see, I see. So if an expression, maybe that is like the lambda. Okay. I think the AI was thinking that maybe. Okay, yeah, but that makes sense though. So, but we only have support for the block right now. So actually, yeah, we have the block. So let's add a to-do here, lambdas. All right, but we have the block. Okay, now, whoops. We can return a function declaration. And of course, we don't get any help here. For some reason, like go to definition doesn't work, but go to type definition works. That's kind of weird. Okay. So name is gonna be just the identifier. Span. I should really add a shorthand for that. Is async is always false. I'm not sure if we're even gonna support that, to be honest. Like have async functions. I'm not sure how I want to do that yet. Parameters, we're just gonna set to an empty for now. I'll add to do parameters here as well. Return type is, well, we actually have this kind of already, so let's do like return type here. Function body is gonna be a block, and there's the block, and the span is gonna be, well, we start at the identifier. No, actually we start at the function, so we actually need this start here, start, and we end at the block. There we go. All right. Okay. I was like, why are there like no errors and stuff? There should be errors somewhere, maybe. Is this even called? Did we call this? No, we don't. Okay, maybe that's why. Maybe type annotation. Actually, not. Maybe type annotation. Skip type expression. We should just we should like return. Now we can do like parse. Maybe type annotation. At this point, except we also need to consume this colon as well. So let's do next token first, and then we do that. So now we've kind of, when this is plugged in here, we actually get the correct thing. Okay, parse let, parse maybe let, parse string. Well, this one is what we're looking for. Oh, need to change this to that. Also, we need to add breadcrumbs. Forgot about that. You need breadcrumbs. Of course, maybe type expression. All right. There we go. Here we are. Okay, let's copy this. Now we have like parse maybe function. So maybe function. There we go. What is this? Oh, self. Return type is question or pointer. Hello Polaris, have a nice day yourself. How's it going? Why is this a pointer? Well, I mean, I guess we can just make it into a pointer, and that's fine whenever we actually implement it. Since we don't actually, we only return null, so that's fine. Whenever we actually start to implement it, we can just fix it then. All right, so no more errors. Let's see. Let's restart. And there we go. No more errors. And okay. Hello. I'm gonna try this here. Lib. Cool. So, okay, but now when we run it, it's gonna like fail. Access of union field expression while block is active. Oh, does it actually have like some kind of function execution already? Interesting. But we want to print AST. No? Okay. Wait, or maybe not actually. Oh, I see. Ah, I see. So this is the this is the expression walker, which resides in run script, and we have like statement expression iterator. So this one, I should probably move this to the AST module, but this is like an iterator on. You take in an AST. And it walks through every expression in the script. So it walks through that. All right, and then because we're using it to get all the import statements or all the import expressions, so that we can pre-parse it and have all the files and everything ASTs ready for the execution later. And but that might change in the future to make it more optimized. Basically, maybe we don't parse until like maybe we do like a lazy parsing or something like that. We'll see. But yeah, so there's something in here that doesn't work, like functions. I didn't understand that the expression was actually like, I didn't understand that this was a union enum. I didn't look too hard on it, but it's like, oh, it's got an expression and a block. Okay, so I guess we add both of them. No, it's a switch. We have to switch on the body, and it can either be an expression and in that case we will append that. I think we can actually do a join there. Or it's a block. And then we do populate block expression block. There we go. What is the name of your scripting language? Runic. RUNIC. Okay, so that is done. There we go. Now it works. All right. So we got the function declaration. Printing is not implemented. So I guess we could print like the name. It's well, maybe we do want to print like the whole thing, but I'm not going to implement that right now. I want to implement actually running the function, because this would member not found on 9.1. What? That's a weird error. Oh, this one not found. Oh, I see. So it didn't find hello, I guess. Well, I guess that makes sense. But okay. What if we don't do that? Unsupported statement. Okay. Interesting. It still keeps going. It looks like. Okay. I didn't actually know that. That's interesting. Like each statement seems to be its own thing there. Okay, cool. Yeah, so this is like in lib 11. This is an unsupported statement, which makes sense. So let's add support for it. So we'll go to the, well, this would be like the evaluator, I think. Execute statement. So we have a binding declaration, we have expression. There should also be a function declaration here. Interesting. Binding actually, that returns like a null. I guess function also should do the same. Let's keep the same pattern here so it's easier to change later. Execute let, execute function, I guess, declaration, to not confuse things, because otherwise it sounds like we're actually calling it. Declaration, yeah. And then we break, there we go. All right. Let's go over here. Let's copy this thing and there we go. And this declaration is a function declaration. All right. Are you an engineer? I am a software engineer, yes. I've been working 10 years as a web developer, but I've been programming almost my whole life, you could say. But yeah, it's just it's a hobby for me. So this is like a fun kind of, you know, experiment, learning experience for me. This what I'm doing here right now, and hopefully maybe people will maybe, you know, people are interested in learning Zig, this program language that I'm using here. It's kind of a new language, and yeah, people seem interested in making language as well, so that's cool. All right, what do we want to do here? What about you? Are you? I'm assuming you are not a developer. Just you wouldn't ask that question probably. About the expression. So this one evaluates the initializer. That is for the other declaration. We have a name. We have some stuff. So we also have like bind pattern. Bind pattern. Interesting. Right, the pattern is something else. So like the pattern is it could be like a discard, it could be, you know, an identifier, it could be like a destructuring pattern as well. But that's not the case for a function, but we could coerce it into being you know, or like we could transform it into an identifier pattern, and then the value would, I guess, would be like a function. So we could still use this function here. The pattern would be, you know, identifier, which exists on here. I'm not sure if I need to clone this or anything. I guess we'll get yelled at if we need to do that. Declaration is mutable. Well, the function is not mutable, so I will set false there. And the value is interesting. We don't have a value like this. We have a block. We need to be able to, yeah, we need to create a like a function value or something. So this would be like a value function. Yeah, there's no such thing, but I guess we'll have to make it function. It's gonna be interesting. What is this? Runtime value. All right, I'm just gonna be a second here. I'll be right back, like in a minute or something. All right. Sorry about that. Let's continue here. Runtime value. Yeah. I was gonna read this comment here. Runtime value representation used by the interpreter. While evaluating ASD nodes, every variant owns its storage. Scopes can safely clone or move bindings between frames. Right. Okay. Except for the scope stack, I guess. All right. Yeah. So we need a kind of a function. Now I guess this could be this is just like I mean, you can't really modify a function. It's just going to be some kind of thing that will be put in some kind of storage, maybe like some kind of identifier for the function, and maybe we're gonna do closures as well. That's gonna be interesting. We'll see. But I think for starters, we're just gonna do... I mean, I guess we could also just store it here. Let's just do like a... Well, let's do a function... yeah, let's just function. Okay, and then, well, and that's a struct. And what we need? What do we need? What do we need? We need the block function body. I mean, I guess we could just get the whole function declaration, I guess. And that's a pointer anyway. Actually, you know what? We probably want some kind of other structure, but for now, I'm actually thinking that we're just gonna do function declaration. So we're just gonna have a function declaration. Also, it's a pointer and const. And when we clone, we will simply move it over. And if you just do that, what you can really do is you don't really care about all this. You could just return self directly, which is the same for this. And it's basically the same here. Like, we don't really need to recreate this. This is just gonna be, you know, self. Because that's the same thing. Like, Zig actually, it does this automatically for you, so you don't need to... Yeah, when we need to dupe or clone something, then we need to do that. But otherwise, if you just reassign like that, that's the same as just returning itself. Because the value is returned as a constant, so it's gonna be... It's just gonna be... It's gonna be copied. Void, same thing. So all of these could be just put into a... It could be put here, and then we don't need all this. There we go. Oh, I see. That doesn't exist. Okay. So let's do. What is that? Front end AST. All right. Where are we? Okay, here. So function, we just put declaration there. There we go. Right. So we don't need to do this. Not sure what this consume this for. Oh, I see. We don't need that. Because it's part of the AST and that's gonna be handled elsewhere. Switch must handle all possibilities. Right, so now we have. So this is gonna be. Well, this is gonna be a value, I guess. Wait, why is it a pointer? Is it gonna clone it? Move. Moves the value out of the union, leaving void in its place. So the call. Oh, okay, okay. But this is a constant anyway. Why do we pass a pointer? Oh, it's because we move it. Okay. Okay, so it doesn't really matter because we're creating the value here and doesn't have anything that needs to be handled. Okay, let's make it a var to solve that. There we go. Now, let's do materialize string here. So we need to support function materialize string. You are not supposed to do that for now, so I will just do this. We might support some of these in the future, but I will just say function there. Or I mean unsupported string coercion or whatever it was. Evaluate member expression. Right, so this is if you want to access some kind of member on a function. And, you know, technically we could support that, like getting some information about a function, but I will just do this for now. All right, cool. Hey, Blue. How's it going? Thank you. Alright, so we have this now. Okay, so now we need to be able to execute the function. So now we can actually we're declaring the function. Let's see if we have any errors here. No. So yeah, so this runs, but we're not actually calling the function. So we are declaring it, and that works apparently, but we're never calling it. So let's try and calling the function. Okay, nothing happens. Okay. So the thing is, we start here because we are actually evaluating a member expression that is, you know, we're accessing the member hello on lib. So what is happening here? we have a scope, which is the thing that we do. We simply return the value, that's right, of the thing. Now we probably want to try and execute this. Maybe it depends on the scope you're in, like the context. I'm not sure, like how do we, because when, let's look at the binding thing. Where is that? Execute let. So we evaluate the expression of the initializer, right? But if it's a pipeline, it's not actually, like if it's a pipeline, it should, like there's a difference here, like this echo actually echoes out the standard out, but this echo doesn't. Like if I put you know, let's say let's do this, and let's say I have like echo hello, right? This would echo hello, okay? But now I will put it in a variable, right? It doesn't actually echo it. So there's a difference when actually like evaluating this expression, you know, depending on the context. We don't want to echo to standard out if we have a binding. So that's what I'm trying to look at here. Like how do we know that we actually want to bind this instead of, like we're evaluating this expression, but how do we know that we didn't want to write out to standard out? So if we go here, evaluate pipeline, how do we know that? Maybe there's some context to that's actually put in the pipeline itself. It doesn't look like it. So I don't know. Maybe there's a special execute statement. This is kind of weird, because otherwise it would just go straight to here, evaluate this, go to a pipeline. Like where's there's no difference here. Handle, executor, run, items. Okay, so we're building up the specs. And we're running it. Maybe it's like at the end of this, like run statements. Wait, what the hell? Render string literal. Execute. So we get a value out. Okay, here we're doing it. We're actually checking, like each statement we're checking, okay, was this a process that just you know, a naked, you could say naked process or something, like without anything else. Like if it was a process handle, if this was the statement type, then we actually forward it to standard out, standard error. I see. Okay, so in the evaluator, there is no distinction here. What was it? What was the issue that I was looking at? I don't remember now. Okay, the issue is here. So this does not run, is the issue. This whole expression should be the function declaration here. And I guess if we just have a naked thing like this, it would just run everything inside. But what if we have like this? Then it should, you know, it should run the thing as well, but it will store the result in here. Okay, so but maybe we need a different kind of result, because these are simple. These are just one pipelines, you know, per statement, but this could be like several. Technically, this could be several statements. Maybe we just extend like the statements that we execute, or we just run the statements inside the function. Run statement. Yeah, maybe we need to, we push a stack, as we push a scope frame, and that would automatically give us, no, that doesn't work. It needs its own scope stack, yeah. Because otherwise it could access things from outside, and that doesn't work. Yeah, okay, so actually the function declaration should include its own scope stack. No, when we execute the function, when we call the function, that should make its own scope stack, which is separate from this. Yeah. We could also inherit the scope stack from the module from which it was declared in, but I don't want to do that maybe yet. I'm not even sure if I want to have that, like a capturing thing. Okay, I think we'll do that. So basically, when you call a function, we create a new scope stack, we run all the statements in it. Yeah. And it's gonna run in its own scope. Oh, we have execute block. Ah, wait. Is this even used? Execute provided block in existing scope. Well, we don't want that. Callers should ensure that a frame is already pushed and ignores the final expression value if it's present. I wonder if you could have like you could have a frame that is like, hey, you know, a configuration on the frame that says that, hey, I'm gonna block all things below me. So basically, when you access this frame and you have like a, you know, isolated or something. So if this is true, then you won't, because, okay, if I explain how this works here, this scope stack is basically, it's your scope, it's where you keep all the variables bound to their actual values in current runtime. And also the functions, function names. So if you want to find the value of an identifier, you go into the scope and you look for that. And how it works is, if you have multiple like blocks and scopes, you have frames, and each frame has its own like you know, list of bindings here. And how it works is, it's gonna look at the topmost frame first, and if it doesn't find your identifier in the topmost frame, it's gonna go to the next frame and so on until it finds the identifier in that scope, and then it's gonna be able to use that. However, now we want to call this function, but this, if you call the function, you're calling from a scope that is like not the scope where it was declared in. So we don't want it to have access to our scope, because then it could, you know, it could refer to variables that doesn't exist, or I mean variables that exist in our scope but that it didn't exist in the scope that which it was declared. So we don't want this, we don't want it to have access to our scope. So basically what I'm saying is that, what if we push a frame that is kind of isolated, which means that it should block any kind of you know, identifier lookups that wants to go deeper than this frame. That should be fine, I think. And then here it's like we have a push frame. Let's just have like options. Actually, let's make this, let's make a frame options here. Or blocking or isolated. Isolated kind of feels like it should block upwards as well. I'm just gonna say blocking and initialize it to false to begin with, and then you have like options here. All right, in it we should bring options in there. There we go. All right, and then of course we need to set options there, and then we need to have options. Where do we need options? Push frame, frame options, frame init options. There we go. So now whenever we push a frame, we can also pass in options, and it would have certain options on it. And then we declare, that's fine. Hang on, so declare find in frame. So find in frame, that shouldn't affect anything, I don't think. Let's just look at this. It looks at just this frame alone, so that's fine. And this one is like, okay, this only affects the current frame, so that should be fine. Here's the lookup function. So the lookup function goes through the last frame first, and then decreases until it hits 0 here. So here we want to check also that the frame options is blocking. Like if it's blocking, then we don't want to continue over here. So if the frame options is blocking, then we actually return null here. Then we stop this lookup. Okay? Because now we don't have to create a whole new scope stack every time. Now we can just push a frame that is blocking, and that will create kind of like an isolated island of frames upwards from there. and hopefully that will prove sufficient. Okay, so now we can just pass the same scope stack around, so that's cool. All right, we could, yeah, so then we could just run this block there. So, yeah, and it's doing it, well, this is a test. Is it only run from tests? Okay, interesting. Well, it's public, so, well, it's not. Okay, so we don't actually use this, but this, we could use this. We could actually run statement, run block. So let's do like run function or call function. Let's just have run function, whatever. Evaluator, scopes, and function. I guess this would be like a function declaration. Actually, it could be a value. Whatever. Let's just have this. And there's an error. And this could produce a value. I guess, well, the value could be void. So yeah, that should be fine. All right. And then we simply, I guess we run the block. Now, yeah, this is also the thing. We don't actually have, I don't think we have return statements yet. So I'm just going to run the entire block. And it's going to just return a void, I guess. Technically, you could treat, oh yeah, this is what I'm thinking as well. Like functions in Runic will be a little bit special, maybe, if you compare it to functions in other languages. Like, because just like in Bash, like every time you run a command or run something, call a function or whatever, it has its own status code. It has its own like standard out, standard in, whatever. I'm thinking like functions in Runic is going to be the same. It's just going to be, it's going to be kind of the same as, you know, executing a command. And what that does is it's going to make everything look the same. It's going to be, everything is going to be similar. A function is just going to look as another another process, basically. That you, or executable, basically. So you could pipe into a function, you can capture out of the function and stuff. You know, calling the function will look exactly the same as running an executable, passing arguments into it, except when calling a function, you have the ability to actually pass in like typed variables, and we will get like type checking from it. So that's the idea. So it's not going to be like you're calling a function with parentheses and stuff. It's going to look at exactly the same as. So basically, let's say we took in a parameter here, which is some kind of string or something, and we will hello, you know, argument from full name, for example. Now, whatever, the capture doesn't matter here. We don't have access to it. But anyway, now we can take this argument like this. So let's say, you know, Runic or whatever. So this function is called exactly like a normal, you know, executable. So it kind of looks like an executable, except it's a function, and it takes an argument. However, the argument could be like an int, for example, and then you pass in a number instead. And the difference here is that now it's like type checked here as like this, and you can do like, you know, any kind of expression that would be one argument here, right? So that is going to be like the difference, because then all of the like every kind of, you know, the first class citizen or whatever you want to call it, like the process stuff, process handler, is going to be the same as just a function call as well. So you could pipe this into whatever, you know, you want, and redirect and everything like that. So basically the functions are gonna mimic the process. And I realized that like in Bash you can also do like the same kind of thing, I think, anyway. And I think maybe in here you can also like make typed, the idea is maybe you could have like a typed standard in, for example, or like, you know, so I don't know what the you know, syntax is gonna look like, but let's say you have like standard in is an int. Well, now standard in is actually type checked, because in here it's not actually like a standard in pipe. It's gonna be more like just a function that gets called in. I don't exactly know exactly, but this could be a potential thing. So you could like, let's say you have let's say you have like echo 5 and you pipe that into like parse int or something like that. So you have a function that takes a string, parses it, and returns an int, and then you can pipe that int into lib hello, let's say, and let's say you don't have this argument here, and we remove that, and then the standard, and then you take standard in is an int. So now you have a typed standard in, and then you can, you know, use this over here, for example. So that could be kind of cool. I don't know. I don't know if it's gonna be super useful or anything, but you know, it's gonna be fun to experiment with. Yeah. So yeah. So I have to keep this in mind when I actually like try this out here. Of course, this is gonna be way in the future when we actually have this stuff ready, but right now I'm just trying to run one function here and with no arguments. Okay. All right. Now, what's happening? So we run the function, right? So what do we need? What do we need? I guess we need to push a frame that is actually now blocking. So it's a blocking frame. This could be an error, so I guess we do that. Okay. And then at the end, I guess we will pop the frame as well. Do we get it back? No. All right. Now we will try run this block. Self with these scopes. So now we can just pass scopes. We don't need to create a whole new scope stack, which is really nice. And the block is just going to be like function declaration body block, because we don't support evaluate like expressions yet. I'm going to add it to do support expressions expression bodies. I mean, we could also have like a switch here. We can switch on function declaration body. If it's a block, we will run it. If it's an expression, I mean, I guess we already have support for it. I guess we could just run a statement that is an expression statement. I think, or is it just expression like this? I don't know. Which is the expression there? Is it statement? Is it? Oh, it's expression. There we go. All right. Now you don't do any weird stuff to this statement, do you? I don't think so. No, it just looks at it and there we go. Okay, cool. So I guess we do have support for executing it now. Okay, cool. And we don't get any weird, you know, scoping issues now. So cool. Do you need a pointer to this block? No, you don't. Okay, nice. All right. And of course, this needs to return a value. So you don't actually return a value. It's gonna be interesting to see how we're gonna deal with the like return statements. I guess maybe we can have, if we're like in a function context or something like that. I'm not sure exactly how we're gonna do this, but let's do, well, this is just void, so, and this is a this could be a value. I guess if it's a null, there's no value. So so if this is null, we could do like or else return void, I guess. I mean, void here. Void should really just be. Oh, it is. Okay. Okay. I was thinking it was not because it looked weird before, like when you declared it or defined it. Okay, and then this is just void. So I guess we just return this. Yeah. All right. Return that. This is so... Okay, expression statement. I'm just gonna do this. So that we don't get everything on multiple lines. And then we get like result. No. Oh yeah, you need to be here. Okay, cool. And if we are over here, wait, there we go. Yeah, okay, this is exhaustive, so we don't need to return anything else. All right, cool. Yeah. So we run the statement, we execute the statement. Okay. But where was the thing? Execute block. Where was the thing where we what is it? Handle? No. Forward. Oh, it wasn't. It was outside. It was here. So this looks at all the statements. No, yeah, and we run the statement, and we get a value out. And the value, if it was a process handle, then we forward it. So basically, now when we call this function, it could have several statements here. Right? So when we call this function, it's not just gonna, you know, evaluate to one value. I guess it could evaluate to every thing happening in here. I mean, it's kind of like a process. It's like a process handle, I guess. Yeah. It should just be like a process handle, actually. Yeah, that should take care of everything. All right. So maybe actually run function. This should actually return a process handle instead of a value. Well, I guess the value is the process handle, actually. Yeah. Okay. Interesting. But then we need a way to run the block as a process handle, basically. Okay, what do we need to do? How do we do that? Value, process handle. It's like we have to make a new one. I guess it's kind of different, maybe. We don't really want to have an ID for it. Or do we? It's so unoptimized. I mean, yeah. It's so like if every function call is gonna be its own process, that's gonna be very costly in terms of like resources and speed. Maybe we want to have a special kind of process handle then that works for like function calls. We want a separate process handle, and then we need to encapsulate both in a common interface. Yeah. So let's make a new thing here. So it's gonna have like, it's gonna be like the same process handle, but it's not a struct, it's a union enum. And we're gonna have like a function call, and you know, a process call, I guess. So this would be the process call, and then we need a function call. And then I'm gonna copy everything first. And we'll see what we need to remove here. So we're not gonna have a process ID. We could still keep these things. Status, stage captures. It's basically going to be the exact same thing, except the only difference is we don't have an ID. And if that's the case, maybe we just have one. Maybe we just have one. You know, once of this, except this is an optional. So if it's null, that means this is a function call. If it's not null, that means we have an ID for it, or that means that it's a process. Maybe what you also could do is, instead of having a union enum, you have a struct, and then you have like all of the common stuff in here, and then you also have like the type, like process type or handle type. and that could be either function or process. So you would do this, put this in here instead, and you would have like handle type, and this would be a union enum, a Euro struct, and this would be either a process, and then we just have what child ID, or a function, and in that case we don't really have anything extra there, and then everything else is common here. The only thing now is like we have to look at the handle type to get the ID and stuff. We could add a convenience function, which has like a nullable standard process child ID, return if handle type is a process, we return the ID, well, we return process, otherwise no. Okay. And then for this, we just delete that. So now we have process handle for both function and process. The only difference is the process have an ID. Okay. It seems like we didn't even use it anyway, so because otherwise we would have gotten some kind of error there. Well, maybe we do. Maybe we will get an error soon. If we fix these first, maybe. You want options, so there you go. Any place that didn't have options, we just add the standard option there. Oh, here we go. Nothing named PID. So, right. So this would be instead handle type is a process. Wait. Primary PID. Get PID. Same thing here, handle type. Now we're just gonna assume this is a process because that's the only thing we had before. Wait, what would you call? No. About self PID. No, that would just be handle type. Why are we doing all this? This is like this is so weird. Oh, it's a clone. Okay, well, whatever. Creates a deep copy of the process handle, so background executions can shuttle results between different allocators. The clone handle owns its own capture buffers and must be deinitialized independently. Okay, well, that's great. AI. All right, no more errors. However, we're not actually calling the run function thing. So let's see, do we, well, okay. It's gonna be a pipeline actually, or a member access. Well, it's gonna be a member access first and then a pipeline, I think. Yeah, so we're getting the value, and the value is the function declaration. Then we actually want to execute that. At a part of the... Okay, this is actually kind of weird. Because lib hello is a function, right? what if you want to store this in a result? So hello result equals lib hello. Okay, now we got the result in lib hello. But what if you just want to alias this function and call it later? So lib hello, and then we call hello, you know, or we want to store it like this. There's no distinction between trying to call the function or just trying to alias the function. So okay, that's actually an issue. Like language design wise, what is going to happen? Oh, okay. I mean, my first instinct is telling me we should always like execute it. If we just call it like this, because it should have the same function as maybe doing this, for example. That should have the same. It shouldn't be a difference between you know, doing this. There should not be a difference there. But I do like being able to like alias the stuff. So maybe we need some kind of special syntax for that. I don't like that, but or maybe we could live without aliasing, to be honest. I guess, yeah, I guess executing will have priority. And if we really need to be able to alias, maybe we need a special syntax for that. I mean, as I'm saying it, I realize that, you know, in Bash you can do alias. But yeah, you can do like alias like this. Maybe that's the thing, actually. Is alias like an executable or something? No, it's like a shell built in. Okay. So this could work. We could have like a special declaration, what you call it, not modifier. Well, maybe it's a modifier. That is like alias. And when you equal to something, it will treat it as a kind of like a pointer to that function. And then you call dir, you will call this function instead of actually executing it. That does make a lot of sense. It does kind of it does kind of hurt me a little bit that we don't do const equals this. You know, you get the result back, but I guess we have to do this if we want to sort of go with this calling convention. You know, because the alternative would be to, let's say you want to call echo, you would have to change the whole. You have to rewire your brain to do this. Like, this doesn't seem right. This seems bad. You know, cat. This looks horrible. Or does it? Treating like executables as functions. I mean, I guess it's fine, but because when you do this, you know, you can say the distinction here. This is different now from this. The alternative is to have like some kind of special syntax where I don't know, something like this, or no, that's not great. I don't know, man. But yeah, okay. Anyway, the whole thing is still up in the air. We might change it later. We might actually end up doing this. I don't know. This seems kind of cool, to be honest. You know, executing the functions like this. I don't know. But anyway, the thing is that we would probably go with this for now, and then we can always adapt later, because this should be the way it should be, like this. You do a function execution that should be stored in this result. There we go. And then we like echo hello result out, or not, or we can say like hello result like this, so that we can see that it's just not like, it's not outputting this directly. Okay. Or we can do this, whatever. Like this. All right. Yes. So now, so we figured that out basically. Now what is happening? Okay, so I was contemplating here on, like, okay, when you have a member access like this, live.hello, what do we do with the value? Because this is a function. So if it's a function, we should call the function. Yes, we call the function. I was thinking maybe we can have like a reference, like if a reference, reference syntax. This could trip many people up in the future, like, oh, I forgot to do the reference. It's actually a random function instead of doing a reference. Yeah, but yeah, maybe like a reference. I don't know. We'll see. So anyway, we have a member access expression. If the resulting value is a function, we have to call the function. But if the resulting value is like, you know, live.name, we don't have anything to call. We just have we actually have a process handle in this case, but you know, for surname, for example, we have a string, so there's nothing to execute. We have a process handle. We actually don't have anything to execute because it's already been executed. It's a process handle. The function, though, is different because the function is able to be called again and again. So we should actually call it here. I'm just going through this in my mind a couple of times just to cement that this is actually what we want to do. I mean, it could change anyway, but okay. So there's so many things going on at the same time. So let's see, scope as, yeah. So we got the value. Now, yeah, we got the value. The value is actually a function reference. I'm just thinking how I want to have this, because I don't want to just put a function here that It should happen in a more centralized place. Like evaluate expression and then a function. No, there's not a function. It's not a function expression. It's a function value. Right. So it's basically, we could do it here. If we get a value out, if the value, so we switch on the value. Wait, you are just a value there. If it's a function declarator, is it function declarator? Okay, function. If it's a function, we have to like run the function and then use the value that's produced from that. So we will return run function, maybe, yeah, run function. Whoops. And that's F. Okay, and that should return whatever value we need there. Actually, it should always be like a process handle, but I guess for convenience we can just do that. Otherwise, we just return the value itself. Okay. Yes, awesome. I think that's correct. I guess we'll find out if there's some weird stuff going on. And the thing is here, we're running the block. Otherwise, we run this statement and return void. This is not correct now. We need to make this into a process handle somehow. So I'm gonna go here, and I'm gonna go here, and I'm gonna go here. And here we have somewhere a pipeline. So we basically want to do one stage, I guess, of the pipeline. Or we can treat the function as a pipeline. We can make a pipeline out of the function and run it here to get the process handle out. That seems like a cool idea. However, we have to adapt this function to work with functions then as well, because right now it treats everything as commands. Actually, you could have expressions as well. Oh, but then it's like unsupported. Yeah, so we have to adapt this to be able to support functions as well. Yeah. Yeah, and here we collect all the arguments and we call. Yeah, that should be the same for the function, to be honest. So the only difference is that the command is actually a function instead. Now, right, so should we then continue to allow this to be an expression like that? There's some little difference between calling a function and a command. So we could probably get away with just putting the function to be like cloaking it to be a pipeline or a pipeline stage and then calling this, except there's one tiny difference, and it's you shouldn't have like a process ID or anything like that. Because if we look at this, we have like command specs. where you have like argv, current working directory, like, yeah, I guess all this matters because the function could call other stuff, which all this matters as well. But we need a way to separate then this command spec with a function. Okay. Yeah, there's so much stuff going on here. You have to like fit this in somehow here. So and then this runs with the executor. This runs a command and gives us a command handle. And we have a run function which is like different. Yeah. So okay. Where is that happening? Up here. So what is the runner? Tracer. So here's, I guess this is the runner, okay. Then we have the executor. I'm just trying to figure out where this function is coming from. Options, context, runner. Okay, I got lost in all this. Run script, no. Go back. Evaluate import. Evaluate pipeline. Executor run. Right? Where does this come from? The run function. Where is this set? This is set from, we have from runner, run with runner, run with runner. What the hell is happening here? Run with runner. Oh, that's the run function. Run with runner. What the hell? This is so convoluted. Why do we have, like, this is the only function in here? I don't, okay, whatever. Oh, it's like a struct? No, it's not. It's a function. Okay, well, this is the run function. So this is running the command, and then we have the run pipeline, which is this function. Executes the sequence of commands as specs as a running pipeline. The standard out for stage n becomes standard in for stage n plus 1. Yeah. Okay. What do we need? So I need to figure out what we need to change in here to be able to support functions as pipeline stages. So here we have like run stage. We get a stage. It produces some kind of PID. Is that always there? Yeah. Actually, what the hell? Oh, it depends on the operating system. Okay. And yeah, so we got a command runner, we got stage run args. So this is where we need to have separate things. Stage run orgs, command spec. Yeah, the spec is what we need to change, I think. We need to have like either argv is, you know, so I don't really know why we did it like this. I guess argv maybe is fine to have it like this, but then we should also have command type. So it should either be a process or I mean executable or something, or a function. Okay. So here we have like command type is equal to, and this should depend on the pipeline stage. So pipeline and then like, I don't know. We have the role command expression, but it's not really used. I'm just gonna add this on top of that. Command type. Well, executable or function. So this would be a stage type if, like, yeah. Let's have this as a stage type as well, maybe, or command type. I don't know. St no. Wait. What? Oh, stage type. Right. Stage type. Okay. Cool. Wait. Why are you yelling at me? But it's not an error though. We're trying every time. Oh, because of this? Okay, there we go. If it's anything else, we return that. So that we can just do return here. Okay. Wait. What the hell? Where do we do this? Erdiver? If scope is active. Options. Is this the only place where we do that? Okay. Oh, I guess maybe we don't need it. Maybe we only need it for expression then. No, because we need a blocking frame though. Yeah. Maybe that could be, they could be like frame options in here, I guess. But it makes more sense to put it here because both of them need a blocking frame. Okay, whatever, let's just do it like that. Oh, you're a void. That's right. Well, we have to change this anyway, so... Okay, so we got a stage type. And we need to fix some stuff here. Parse pipeline stage, right. So this should always be... Actually, we don't know. We don't actually know if it's a command or if it's a like if it's a executable or if it's a function at this point. We don't actually know that. That would have to be known in runtime actually. So the pipeline stage, we don't actually know the type. So what we could do then is we could actually look at the command spec. We could look at the first thing here and then run it. However, we could use the current scope to get the function from that, perhaps. We need like we need two scopes actually. We need like the scope where the function is called from, and then we also need a scope where it should be called in. Maybe. Or maybe we don't need that. Maybe we just need the one outside. Okay, anyway. Alright, so you don't actually have this. Good. And you're still complaining. Okay, now where did we go? We need like pipeline. And I mean, maybe we could do it here actually. Oh yeah. Because here we could look up the scope. We have the scope here. Yeah. That's true. Yeah, okay. Stage type. So this would be like command type. Let's do like union enum. Because we need to know the function declaration. We could just do the... Yeah, we could just do like function is... function declaration. And then otherwise we have executable. Alright. The problem though is that if the command runner doesn't know how to run this function though. I don't know. But I think it has to happen in here. Run the pipeline. We have a command runner, command spec. What do we need to do here? We only have this. This doesn't bode well here. We need to either store like the executor here, or we could pass it in. I guess we could pass it in maybe here. We could pass in a way to evaluate the function. Run stage. Yeah, this has nothing to do with the rest of the like evaluation of the functions and everything. This is only considering running executables here. So what do we need? We need like the evaluator, I think. Yeah, we need this guy, the evaluator. Where did you go? There you are. You is this you? Run stage? No. Run pipeline. You need evaluator. And that is going to be, I think, interpreter. Yeah. Actually, this kind of nice pattern. Like if you have an outside, you could do this, so you can actually see that. Okay, yeah, it comes from outside. I don't know. But yeah, it's nice in this case anyway. Because it might change and you have to, it's nice to know that, okay, this is actually somewhere else directly unused. Yeah, so whoops, the daisies. Okay, now how do we wire this up? So now we have the mains to run the function, perhaps, hopefully. We probably need the scopes as well. No, we don't. Yes, we do. No, we don't. Yes, we do. No, we don't. I don't think. Okay, trace pipeline start. For each one, we run the stage. Okay. So I think, yeah, we need the evaluator here as well. Evaluator. And over here, we need to add this. Please. Now, empty command is weird. That's a weird error. Yeah, we don't actually make a child. This is kind of cool here. What we do, I mean, technically we could. No. Let's just call this, let's just run this as a bunch of things. Okay, switch on the spec type if it's an executable. We will do everything that we're doing down here. We'll figure out if we can run stage executable. Whoops, did I see? Right. If we can like centralize some of this functionality. Okay, and then so this would be just return. Let's just do return self on stage executable args. But if it's a function, we will get the declaration here, and we will do run stage function. And of course we need args value a tour as well. Run stage function. And args stage run args error stage execution. Okay. What do we do here? We need to run this function, and we should make that public because we have a run function. Run function. Oh yeah, we need the scopes. Well, I mean, technically we don't really need the scopes actually. We don't actually need the scope. Like, this is kind of pointless, to be honest, like doing this. Now that I think about it, like, why even put this here? We're gonna make this, we can just make a new scope instead. Yeah. Huh. Do we need to store that result somewhere? Okay, well, not now, at least. But maybe we'll just keep it like this, because here I will make a new scopes. Except we don't have a scope stack. There we go. And you need allocator. Good, we have one. So now you're a scope stack, and now we can just simply pass that in here. So that's fine. And we have a function declaration. So we're basically running this function in an isolated scope, which is fine because it's all doing that anyway inside. Okay, and then we get the value out. I guess if this fails, we need to sort of figure out what to do with the error state. Like, if this fails, should this like stage fail? This is kind of the questions that we need to like iron out, because yeah, like in Bash there's like different modes you can set. So like, I'm not an expert at this, but apparently you can like set pipe fail or whatever, and that will exit the whole, I think that's like exiting the whole process. Now don't take this, but basically that's what you know, you could set that the whole program will fail if one of the stages fail in the pipeline, or that just, you know, it just silently fails and it continues to execute. And if you wanted to store the result somewhere, you got the result up to the point where it failed, and yeah, something like that anyway. So this is kind of the decisions that I have to make here. Is like, if this function like return like gets an error here, like what kind of error can you get? Like this error, this is like a runtime error. This could be like referencing a identifier that doesn't exist, for example, you know, things like that. So what happens in that case? We should probably have like an exit, like a status thing for that makes it like we're kind of simulating a process that fails. So yeah, so let's do that. Like if this fails, we should have like a and also the kind of weird thing about functions is that it kind of has one extra like value. So in a process or an executable, when we execute, it's gonna have a bunch of different, you know, results. It's gonna have like an exit code, it's gonna have standard out and standard error. So it kind of has like 3 different, you know, values that it spits out. But a process or a function is, I mean, as I've like defined them here, it's gonna have exit code, it's gonna have standard out, standard error as well. However, it's also gonna have a return value. So it's a little bit different, and it doesn't really mesh with executables. I mean, we could do this. We could treat like the exit code, could be the return value that you get. However, if you pipe something, you're actually dealing with like standard out, standard in, or you know, you can redirect as well. But the return value is really not part of the pipe line, really. So that just gets thrown away basically. So it's kind of like, okay, do we want to use functions in that case? Like you could, if you, for example, you have a function, you know, hello whatever, and you provide some kind of integer, and then you have another, later you have like hello result equals hello. Okay, so now, you know, hello results is equal to whatever hello spits out, except it's actually like a process handle, and it has several different things in it. So it has, you know, exit code or status or whatever, and it has like standard out and standard error, but it also has a return value, which is something, you know, I don't know, 1, 2, 3 or whatever. So that is what this would be. The question is like, do we even need this return value? Should we treat maybe the exit code to be the return value? Like, you could have, because you could have like an error as a return value, you know, and then the exit code could be kind of treated as the return value, because it does kind of make sense anyway. Perhaps. So it's kind of trying to like shoehorn a little bit, like, or, well, I don't know. It's kind of like defining an executable in a different way, it feels like. It would be cool if we could fit this here so that it would be kind of the same. Like exit code would be, you know, I mean, I guess it could be something like, you know, success, and then you have like the return value is whatever value that you want to have, and then like you have error is, you know, whatever error you get. But for a process, then it could be the same, except, you know, success would have basically be, it would basically be just a void, because it's just always the same, and then error is some kind of number, you know. Yeah, because then we don't really need to worry about the return value as a separate property. We could treat exit code as the return value. I don't know. We could do this, because the thing is, like with the processes, normally, like looking at the exit code is like, it's more important to deal with the standard out, I guess. Because that's what you're trying to pipe in, pipe out, like doing transformations on that. I don't know. Like, it's only if you have like this function, and it kind of depends on the purpose of the function. The purpose of the function is more like, okay, well, actually, you know what? The standard out and standard in, if they are typed, let's say you have like parse int, it takes a string from standard in and it produces, you know, an int out, and as I've shown, like shown before, like you can have like an int is equal to like echo 5, and we pipe it into parse int, so that would like convert this into an int, and you get the int here. So then you get like typed pipes, basically, you could say. What solution are you trying to accomplish with this scripting language? Are we better than another scripting language? I mean, I'm not trying to be better than any other scripting language. What I'm trying to do here is I'm trying to make a scripting, like a bash-like scripting language that I can use. Instead of like I'm making this language instead of learning bash is basically what it boils down to. And then you could have other options here, like, you know, radix or something, you know, to modify whatever this is doing. So you can deal with standard in, you can have like other arguments, and in this case, you know, you could say 10 here, for example. So you would convert this, you would read this as a, you know, base 10 number, and it would produce an integer for you. So this would be 5, of course. Or if you put like A5 16, that would read it as hexadecimal, and yeah, and so on. And it will produce, you know, the actual number in binary, I guess. Something like that. Yeah, and if it fails, you know, it makes sense to use the same kind of structure as the processes, to keep everything the same, so that functions and processes or executables kind of feels the same, but a little bit different. But pros, like executables, are always, they always like work in strings. But then the functions could potentially have like typed pipes. Looks so standard in should be a pipe or a type that you can say, and then this. So let's say you have another function that is like, I don't know, add 5, you know, the usual, and then this takes in an int and produces an int, and now this doesn't, this can't error, you know, as long as this is an int, which we will make sure with the type checker, you know, so we will statically know that this will never fail, basically. And so we just return we return standard in, you know, +5. So return will actually, that will actually be like the exit code for the function then. No, wait. No, it's going to be the standard out. So how would you do? Yeah, no. Wait. Okay, so how would you... No, yeah, okay. So let's say this. Let's say that the result type is always going to be the standard out. Okay? But that means that you can't have like echoes in here. Like if you have an echo here, that kind of destroys the whole thing. Because if this is supposed to be an int, you all of a sudden you get this echo here. That doesn't make sense. And we have basically no way of knowing statically that this would produce... maybe we do actually. Well, it depends on the scope. No, well... Yeah, if the scope doesn't have a function, the named echo, we will assume it's a command, which can potentially standard out something. So so maybe this is not, well, and also what if you just want to add some debugging, some debug logs or something? I guess you could use the standarder for that. Yeah, maybe this is not such an easy thing to think about. Maybe I need to sleep on this. But I for sure want to be able to do something like this. Like be able to parse, like pipe into a function defined by the language, and then continue on the chain with like a typed pipe. However, this is gonna be weird to think about. It's like what we could do maybe is treat this differently, like standard out happening from like executables in a function. No, that should just be a standard out. Yeah, I think that if we call this, we need to statically analyze that echo is either a function or a command. So that's going to be the semantic check, I think. If we find out that we're trying to run a command here, then that clashes. Like if this is not a string, then that's going to be an error here, I think. Yeah, I think so. I think if you want to print some debugging messages, maybe you could use something else. You could use like @echo or something. That would actually, you know, log it out to standard out always, instead of putting it in some variable somewhere. Something like that, maybe. So this would produce like a semantic error because of mismatch of the pipe type. And this would actually be legal because that would just log this out to standard out. It's like a debug log. Something like this, yeah. And then the exit code. Yeah, the exit code is basically, we're not going to actually keep any values in success. Success is just going to be, this is just going to be this every time. Because in the case of an executable, it's always going to be 0. In the case of a function, the resulting type is actually going to be the pipe, that's actually going to be the pipe out. It does make sense as well, because if you then have like, okay, if you say like hello is equal to echo hello, you know, and then you use this, whoops, you then, you know, the standard value of this is standard out, right? So if you, for example, echo hello, that will take the standard out value and you know, coerce it or put it as a string here. If you echo int, it should also take the standard out. So we have a common, it's like a common interface. It takes a standard out, but this happens to be another type. It's not a string, it's actually an int in this case. And then you could coerce it into a string here. So yeah, that actually makes sense. I'm just trying to figure out like this, like things like this could trip this up here, but yeah. That is kind of cool. Okay. All right, but that means what? Okay, I'll keep this maybe around here. Let's name this something. I don't know. Well, this is gonna be like function exit codes. No, I'll just search for something in here. All right. So what do we need to do? We have a new scope. We evaluate it. Right. So what's gonna happen if there's an error here? Well, I think in the, like right now we can have semantic errors like a variable that doesn't exist or anything like that. But if that happens now, we would have to catch it here and now, and that means that potentially any function could have an error. But in the future, this could be semantically identified as, okay, you can't actually error here because the this can't error and this can't error, but this can error, so we don't actually know if this can error. So this would be this would be like, okay, well, since this can error and you don't have the error type, we're gonna tell you that, okay, you need to either add the error type here or remove this here. But if you remove this here, then this function can never be an error. So that's kind of cool. But for now, I think every function can actually error. So if it errors, we're gonna produce some kind of error thing here. So we'll do like catch error. Okay, what do we need to produce here in the end? We need a stage execution. So what is that? We need all this crap. Well, PID. We don't actually have PID here. Unless we choose the parent. No, I don't know. Maybe this should be like a null. Execution. Yeah, this could be nullable or optional. Started at, finished at. So all this should be basically the same here. Started at. And I guess finish that is after this is done. All right. So we'll do result is gonna be either wait. Either it's gonna be like success. Wait, no, that doesn't work. We need like this, and then break. No, let's do. Wait, no, let's do if. Yeah, if. Oops. If else. So if this is true, we get the value out. And we break with the value or success. I'll just make a union enum on the fly here. So just do like success is a value and error is error. Wait, what error do we have? Yeah, just error. All right, and then that's gonna be a result. There we go. And then here we will break with actually we can do this. Could do dot there and then dot success and or dot there and then dot error. Maybe. Oh, wait. I think this is like script context. Yeah. No, it's, wait, it's not. Where's this value at? Valuator. Where's the value? Interpreter value. Maybe just interpreter value. Interpreter value. Evaluator. Wait, it is there. Why? Oh. What the hell? No, that's sig. Oh, root, that's sig. There we go. Alright, there we go. Yeah, okay. So, either we have a value or an error. If this succeeds, we get a value out here. If it errors, we get an error there. Alright, now, so the status is what? Index, term, exit code, signal, okay. All right. I think the exit code, we could put a value here. No, not the exit code. No. Hang on. Well, actually, it could be either like U8 or an error, like a runtime error, something like that. Runtime, no. So error. I wonder if you could put any error here. And then, or it's a byte. Okay. Index, what the hell? Is this the index from the, like, which stage in the pipeline maybe? From term, args index, okay. Could a function have term signals? I mean, I guess technically, like, if a function calls some kind of read from the keyboard or something, or it waits for something, and then you get like an interruption signal, then it should be the function that's currently being ran that should get the interruption signal. So technically it could get that. Now but I think the usual like bash behavior is like just aborting the whole bash process, I think. But then it could have, you could do things like traps. So basically, you know, a process will run and until it's done normally, but it can also receive signals from the operating system. If the user, for example, presses Ctrl+C in the terminal, it sends a sig in, like an interruption signal that tells the program, hey, you want to quit, and then the program can actually have handlers for that signal. So if the signal is, if you have installed a handler for the signal, it will run that function instead of just killing the whole process. So if you want to do some kind of cleanup or something when the program should exit, then you want to install a handler for signal interruptions and handle that. And in Bash, I think you can have like a trap. It's called that. You can trap certain, or maybe that's an executable actually. No, it's a shell build. Okay, so yeah, so in Bash then you would use like trap and like zig-int or something like that. I don't remember exactly the syntax here. Maybe it's just int. I'm not sure. But then that will tell, and then I think you put like a function name or something like that. Then it tells Bash to register an interruption handler for zig-int signal, and it will call whatever function you put here instead of exiting the whole process. And a function would, I mean, I guess a function would have like everything that a process could have, I guess. So I guess it makes sense if it has a term and like a signal as well. But how would we know which one it would be then? Okay, I guess we don't care right now. I guess we just want this to work first and foremost, and then we can figure it out. So let's just, you know, we have a term. Let's just say, you know, it's gonna be whatever, exited with a code. Yeah. So this would be like exited. No, wait. Signal stopped, exited. Yeah, no, it's exited with a code, except the code is now special. Okay, so this would be like exit code. I guess we will move you there, and this would be like the exit code. And you, oh, okay, this is a built-in. Okay, so then we'll make a wrapper. We'll make like our own term, which is a union even. So it could either be from a process, which uses the normal thing, or a function, which is the let's just do exit code for now, and we can augment it later. Right, so then this would be the term instead. Okay. You are an exit code. Now, we switch on term. We can either be a process, which means we want to switch on that and then do this, or we can be a function, which means we set the exit code to be well, I guess only if this is an no wait, it's just this. This is just this actually. This is the exit code here. Hey, I found a use for mixing conventions here. Ah, there you go. Okay. But this exit code is a bit different. This is going to be a byte of this code here. Okay. Oops. Now you are going to be a what? Man, there's so much. There's so many like small things you have to consider. Wait, where was the term? Okay, hang on. So this is the code. It could potentially be a success, right? You can be like, I mean, this is either success or error. This is like only an error. So, well, I guess we also have success. All right, let's just add success there. And here's like exit code. Let's do if okay, success, else we do that. And here we will just do so we'll do like exit code is gonna be if result is a success, that's gonna be success. Oh, I see, we can do it here then. Okay, so we'll do like exit code here instead, so we don't actually need this. Well, we need to keep the value though around, because that's going to be the standard out. Also, we need to change so that standard out can actually be like a string, or I mean something else than a string. Oh man, there's so much stuff here. Like I'm contemplating whether or not to actually just skip this whole implementation part of this part, like the pipeline stuff, and implement that later and only support executing a function like separately. But if we do all this, like we will get like some really cool stuff. So I'm just gonna keep going and see where we will hit some kind of wall, because it feels like we could, but yeah, okay, well, we have the result. Let's just actually let's do we will do a switch. Makes more sense here. If the switch, if it was a success, we will have a success. If it was an error, we will have an error. Which is the error. Alright, so that's our exit code. Why are you not working? Oh yeah, forgot about that. Maybe because of this. So this would be the exit code. There we go. What, no errors in this file? That's weird. Okay, so we have standard out, standard error. Maybe we actually just don't do those then? Yeah, I guess. That's an easy way out here. Maybe. Missing field command type. Do you really need a command type? I think you do. Yes, you do. All right. So you are evaluate pipeline. Where do we deal with the function stuff? I think we don't right now. I think we need to implement this here. So basically, if we find a function with the same name as the first argument here, we will know if it's a command or a function. So basically here is like function declaration is going to be try scopes find or look up the name, and we get a binding ref. Well, it's actually not try, it's or else. So okay, this is like binding, and the function declaration is going to be binding like if binding okay, what do you have, like a value? Okay, so value, I guess we could switch on the value to see if it's a function. Alright, otherwise it's null. So this is gonna be like optional function declaration. Actually, it's a pointer to a const, right? Or not? Is this called a function? Yes, it is. All right, there we go. So either this is a function or not. Okay. Here we will do like what command type or whatever. I would just set you to the command type. Command type is a command type, and that is from command runner maybe, but it's not exported. Command spec command. Okay, let's do command type, and we'll take this. You are command type. Okay, so now we can take command runner dot command type. Command runner dot command type. keep it undefined for now. And then we'll say like if this is a thing, command type is equal to a function with this thing. Oh yeah, this is a shadow. So let's do our little trick. Okay. I think actually we need to do this. We need to have this as a thing here. Yeah. Otherwise, command type is gonna be just an executable. Okay. A little bit, you know, a mazy labyrinthian here, but whatever. Man. Expected type, whatever, found void. How's this a void? Oh, I see. Oh, I see. I need to add else null here. I mean, technically, we could just do this. We can move you up here. And then we can just do like if scopes lookup. Come on. Name slice. We get a binding. And we need to check switch on this value. And if it's a function, we will set command type to that. Otherwise we fall through. God damn it. I want to be able to go into the else here, but I can't. Okay, whatever. Then this is executable. And here else command type is executable. Alright, and then we don't have to do all this. Well, we do need this though. No, we don't actually. There we go. Okay, so a little bit simpler there. Okay. Wait. So that's the command type. Okay. I want to go back here because it feels like we're missing something. I just want to make sure that things are happening here. You know, we're running the stage. We get some kind of thing. We get like the stage execution out. It feels like we're missing something here. Okay, what's happening over here? Executor, run pipeline. You need, right, you need the evaluator. So that should be here. No? What? What? Okay, are you even called? Yes, you are. Oh, but then context is supposed to be command bridge. Runner and map. God damn it. Where's the evaluator? Like, I want this to be this, not this. Or I mean this. Evaluator, well, command executor, run function, from runner run. Could we could add another context. We could add like we could add the evaluator to this context, I guess. Sure. So we provide another context here. Maybe. What do you have? Evaluator. You have the executor. Man, this is so like there's so many different parts that's moving here. Who are you? You're the evaluator, right? The evaluator has everything, basically. Command bridge. I mean, I guess we could add it to command bridge, maybe. I guess we could add, like, the evaluator here. Maybe. I mean, we need it, so... Or to the runner, I don't know. Encapsulates lower level mechanics for spawning external problems. Let's just do like evaluator here. There we go. Problem solved. Where is the evaluator though? No, we should have it. Wait, runner. No. What the hell? No, this creates an evaluator down here. Yeah, that's right. So the bridge. But the bridge, the evaluator has the bridge. Wait. Man, okay. This passes in here, right? Yeah. But it's like from here, where do we get it? Okay, let's just add it here, actually. It just feels like something is gonna be messed up here somewhere. So here we don't have it, so I'm just gonna set it to undefined for now, you know, whatever. And then here we're gonna do bridge evaluator equals to evaluator. Wait. Oh no. We're just gonna wing it here. Bridge. This is so stupid here. Okay. Now. You actually, do you have the bridge? No, you don't. You will say bridge evaluator. I have no idea if this will work, but I guess we'll find out. Right, we still need to fix this, but let's see what's going on over here. What's going on over here? You need to be a term. So you are that. So this would just be, you know, process or whatever it was called. Yeah. That's fixed. And this one from term. What is this? Is this a separate thing? Okay. So we just change that. You. Right. So this is like run pipeline. So we don't know if we have an ID. A PID. Primary PID. What is that used for? Oh, that's okay. That's how it works. It's like each process will spawn its child, or how is that? How does that work? Because this just refers to the first one. No, wait. No, yeah, we run the stage. We don't. No, that's not how it works. It spawns it here from our main process. But why would we get the first one and not like the last one? Okay, that doesn't make sense to me. Why we would like just take the first one, but let's make this into an optional. And I guess we just pick the first one. I don't think this is like gonna do much, but if primary PID is null and wait, started at, oh, it's the started at, okay, well that could be kept there, but if primary PID is null and if we get a PID here, we will set you to you. What? That doesn't work? Okay. Okay, and here we might not actually have this yet. Also, we don't know if it's a process or not. Well, we do know, actually. We know if this is null, then we know it's not a... Okay. Let's say that it's null and... Actually, this should be like undefined. Be more correct, maybe. And then... if this is... Well, we just set this here then, I guess. I don't know. Well, whatever. Okay, there we go. Started, finish, yeah. Yeah, okay. So now, if we have a primary PID, ppid, then this would be that. Otherwise, we would have a function, maybe, or There we go. All right, what's your issue? Expected this, found that. Yeah, that makes sense. You are an exit code. No. Or exit result, maybe would be a better term, but whatever. Let's do this. Okay. Yeah. There's a lot of things we need to fix here. Now, what is your issue? I think it's like you can be a whole bunch of errors. However, it's not necessarily the same set. No. So this is kind of the issue here. This is set to like this kind of error. What if this is like an any error then instead? Let's just do that. Does that work? Okay, cool. Standard out owned. It got owned. Oh, now it's missing. Okay. Well, you know what? I'm just gonna set this to an empty string. And we'll add to-dos here. Fix when implementing what is it? Typed standard out for functions. Yeah. Okay, that's it for this file, it seems. At least no more compiler errors there. All right, so let's see. Let's go evaluator. Okay, what's going on here? We might not actually have an exit code then. Okay, so if it's a process handle and we do exit code, we might get like, we might have like an error. Do we just say set this, do we just have an exit code value instead? Or, you know, even better, I'm just gonna return an error not yet implemented. I'll just put that up here. Or unsupported. Okay, unsupported member access. Yeah, there we go. That's a little bit more, you know, explainment. No. Here, unsupported member access. There we go. Got around that. Okay, here we go. Here's some weird error now. So basically, this error depends on the, I guess, command runner error. Is this gonna be like a circular dependency or something? Hang on. Let's backtrack there. Expected this, found that. So actually, I don't think we need to change the error type. I think what we need to do is this expects a value, right? What did I say about this? So this is a void. Hang on, I forgot about this. What to do? Function declaration body. Okay, my brain is like resetting right now. I can feel everything like just flowing out or disappearing from my thoughts. I don't know. Okay, I need to like, yeah. I think it's like unloading the past I don't know, half an hour with all those weird things. So run function, what would this produce? Run function. Let's see. Well, I guess, yeah, no, wait. Doesn't it produce? It produces a process handle. Yes. Okay, process handle, yes. There we go. Now we're back. Process handle. You will just be a void for now because we don't even have things there. We don't even have return statements. We don't have types. We don't have anything. So basically, you're just gonna be a void thing. Let me do this. So we need to run the block. And wait, hang on. We run the block, but we need to run it as a no, wait. We don't run it we don't run the block. Wait, no, we do run the block. Okay. I think what happened here is like a crisscross thing. The run function is called from the command runner to be able to execute the command, like a function in a pipeline stage. I think. Yes. So we are running the function. Now we don't wire up standard in or anything like that yet. We don't have support for that, so I'm gonna add a to do here. Fix standard in wiring when implementing that for functions. All right. But for now, it just runs the function. And from here, we actually produce. So basically, when. Yeah, so we don't really care about the value produced here. I mean, we get a success value here, but I don't think we actually do anything with it. No, we don't really care about the value right now. What we do is, I was thinking like, oh, we run the function from the evaluator. We actually don't. We only run the function from the executor or from the command runner, because the command runner is the only place where we get a process handle. Every time you run a function, you get a process handle. So actually now when we run the block, the only thing we need to like do, we don't return this, we just return a void value here. We don't actually return a process handle here because we can't actually do that. What we need to do is that when we encounter a function that we're calling, we need to convert it into a pipeline and then call it. Or yeah, and then run the pipeline. Okay, what the hell are you saying here? ACS expression. Oh. You are a pointer. Except what? Oh, it expected a non-pointer? No. Right, you're the expression. From expression. Wait. What? No, from any type. Oh yeah, I see. Statement. Expression statement. Do you have a convenience function? No. The expression doesn't have a span, I don't think. Or does it? No, it does. It does have a span. Okay, fine. It doesn't matter at this point, but... Or maybe it does. Later, maybe? I don't know. Anyway. Okay. Man, there's so many things going on here. Run function. Okay, wait. Is that it for compilers? No, we have a couple more here. But basically here we're returning a void. Here we're returning this. But it doesn't really matter. The only thing that matters is if we're like erroring or not right now. Okay, so what is happening over here? Exit code content. So right, so either we have this or we have 1. Okay, so you will be a byte 1. Let's just say that to have something here. What? Okay, is that better? Yes. Exit code, command runner, exit code. It's gonna bubble up here in a bunch of different places. I think now we don't actually need to annotate this. It just didn't know what the resulting type would be. Oh, wait, though. Okay. Actually, no. This is a success. We could also do like... we could do... from byte or from process byte wait, and this will produce an exit code, and if byte is 0 we return success, otherwise we return a byte. So now we can do this or from process 1. All right. You are an exit code. And you are also an exit code. Command, so runic, command runner, exit code. Actually, no, wait, this is different. This runs out to the main function, yeah. Well, I guess we could keep the same. What is this? Print tokens. We just need to no. This one, dispatch. Whoops. Should probably have that like available straight up. Alright, and now it's over here. So we get the code here. We're gonna check. If it's not equal to success, we will print the code. However, we can have a format. That's pretty cool, actually. I mean, whatever. Let's go with it. Let's not think about it too much. Let's add a formatting function. This will be, you know, self is an exit code, writer, and we will just write. So basically, switch on self. If this is success, we will write, you know, write byte 0. Without, it's kind of weird if we would write success. Let's just say 0, maybe, because that would be the actual exit code, like from this process. And then we have byte. That would be like print byte, and then we have also, we need to let's just try that. And then we have the other one, which is Now here we can actually do like print, and we can print the error there, but we also could do like in parentheses, and that's the exit code, or the other way around. We could do print the number here, which is going to be like 1, I guess. You know, we could do like get error code or something, which would be like U8 exit code, return switch on self, and if we have success, that's gonna be 0. If we have byte, it's gonna be, you know, byte. If it's something else, it's gonna be 1. Okay, so then here we can say well, yeah, but then we could do this to get self get error code instead, and then here we'd actually do get error code, but then also the error here. So we get a little bit of extra. If the failure came from like a function, we get like a little bit of extra error there. Okay. What else have you got for me? Ambiguous format string as specific. Okay. You should be U8. Errors fine. That's an error. You are success. Where is this coming from? main maybe. Wait. Found exit code. Right. Let's just use the same thing here actually. If exit code is not equal to success, we will exit with exit code get error code. Haha. And then you will be success. You are gonna be like this. All right. Where is this print coming from? Okay, we need to do this. We need to do sig build, reference trace. That's the other thing. Stage trace stage. Trace stage results. 281. Oh, here we go. Exit. Okay, what else do we get? Oh, trace summary 3, 5, 6. Three, 7, 3. Okay, just this one left. 2, 7, 2. And yeah, I think this one is like that. Oh, we got more. 281. There we go. Anything else? No. Wow, it compiles. How much would you bet it actually works now? Oh man. We run the function. We actually produced a value like. Hang on. Run function. Yeah, we call it here. So this is the error here. What we need to do here is we need to set up a pipeline with the function instead. So we get the function. We will create a pipeline here. So actually, let's make a let's like run function as pipeline. There we go. So I will make that function. Let's take this signature because it's going to be the same as pipeline. Good. All right. Now, what do? We just create a pipeline. This is a pipeline that comes from where? Command runner? No? AST? Yeah. We make an AST. Hello, not Slayer. Don't forget to take a break. Yeah, thank you. I'll probably quit here in a second. I'm running out of time here. It would be really cool if this could work, if we could make this work here. All right, we're running it as a pipeline. How are you doing? Span, it doesn't really matter. I'm just gonna say that this is the function declaration span. Doing fine, great. End of the day. All right, cool. Gonna sleep soon. Oh, I see. I thought you meant like end of the work day. Oh, so you must be east from here, because here it's like almost 5 o'clock in the afternoon, which is basically my cutoff time here. So Southeast Asia. Okay, cool. Let's see. All right, yeah. We only have one pipeline stage, so it's gonna be. I'm just gonna say this so I get more AST. What the hell? Okay, this span, like the span doesn't matter. Come on. Roll. Command. Payload. Command. I think. Maybe. Yes. Okay, and then we have a bunch of stuff. Where's the run pipeline at? Oh, that's the runner. Right. Name. Oh, I see. Okay. So name is gonna be function declaration. Function declaration name. Oh, that's the same type, right? No, that's a. All right. So it's gonna be like let's just do string, expression, or word. Let's just do word, because that's just a string. Wait, no, it's not. Text and span. From token. Alright, that's the name. Then we have arguments. Let's do empty for now. We're gonna fix this when implementing function arguments, which we don't have right now, or parameters. Background. I mean, yeah, okay, that depends. But we don't support this right now for functions. So fix this when implementing background functions. Background support for functions. Capture, I'm just gonna say no. And same thing here. Fix this when implementing captures for functions. We have environment assignments. Why is that like a special thing here? Okay, and then redirection. Okay. Fix this when implementing redirections for functions. And this one, I'm not sure what to do with this. There we go. That was easy. Okay, we got the pipeline. Now we just run it. So run pipeline. Where is this? Run with runner. Run pipeline. Context. Wait, we don't have like evaluate pipeline, or is it evaluate pipeline maybe? Yeah. All right, so it's this one, evaluate pipeline. So let's just call this then. Evaluate. That's so hard for me to say. Evaluate. Scopes and pipeline. And then we do return this. Are we done now? Are we calling this, by the way? Yes, we are. Okay, cool. So now when we encounter a function expression, we run it as a pipeline. We create the function as like a pipeline thing. We will evaluate this pipeline. So that will have the same flow as, you know, executable pipelines and stuff. And it also means that you can now have like functions in a pipeline as well, because the pipeline here will actually we don't know if we have a function or not. We're gonna check it here. No, wait, here where we're looking up if the name is in the scope. If it's in the scope and it's a function, then it's you know, we treat it as a function. Otherwise we treat it as an executable that you're trying to run. Pretty cool. Stream tomorrow or next week? Not tomorrow, maybe. I usually don't stream at on weekends, but probably next week. Sorry, I didn't see your message until now. All right. Cool. Cool. So is this now fully connected now? Maybe. Let's try it. How much do you want to bet it works? First try, basically. Okay, so that one runs great. Will this now run? So what are we doing here? We are, let's do like the simplest thing here. I'll just remove all this. So we'll import lib, or we don't even need to import anything. Let's just forget about lib for now. We'll make a function which you know, doesn't return anything. Let's okay, so we're not gonna see anything that the function is doing unless we like echo something out. However, I just want to see if this works. So I'm gonna say hello. This is like the most basic you know, program that should run for the function. And there we go. Not even that works. Okay. So it fails at run block. But command runner run function block. What is it trying to do? It's trying to deinitialize with the allocator. Okay. The result is deinitializing the result with the allocator, and then it fails. Okay, this could have something to do with the command bridge having the evaluator and the evaluator having the command bridge, you know. But yeah, not sure. It's hard to tell. Okay, I'm trying to feel it out here. Let's see, evaluator. 100. What the hell is this? Result take? Okay, I've never seen this. Block result. Take last value. Oh, I see. So blocks could have like it. Okay, I've never seen this. Run block. Okay, so it's like executing the block and then we get a block result. But we're deinitializing it at the end, right? And what does that even do? It deinitializes the inner value. Okay. And you will return a block result. It basically, we don't have anything in here. Like it should be like it's just an empty, you know, there's no statements. So what happens then? We don't go in here. We don't have a maybe value. It's just like if we don't have a value here. Store last value. So I mean, it's just that this is null, I think, and it doesn't go in there, right? Because we don't have any statements, unless there's like a kind of like an empty statement that doesn't do anything. Maybe let's look at the printing not implemented function declaration. No, what? Wait. Yeah, function declaration. Let's just make a quick printing of this so we can see what's happening here. So function declaration, and we have the span. Let's do like identifier. Where is it? Print identifier? No. Render identifier. What? I guess we just write all. Function declaration name dot name. Yeah. And then I want to write. I want to print. I want to say statements. Like number of statements. Oh my god. I just realized why this means like length in, I think it's Lua. Because you're basically just saying number of elements. It just dawned on me. Okay. And this is gonna be function declaration body. Okay, whatever. I'm just gonna do block statements length. So I'm just gonna look. Okay, how many statements do we have? Zero. Okay. 0 statements. What if we don't do that? Okay. Yeah. Okay, 0 statements. Okay, that's good to know. Is it set to null by default? Yes, of course. Let's go back to push frame. So we don't ever go in here, and then we just do that and return and this result, which, you know, in the end it should just be null. So when you initialize it, we should just yeah, nothing's gonna happen because this is null, so it's not gonna get in here. So we get the so this is the block result from this. Yeah. So why are we getting a seg fault here? Or a general protection exception? Oh, it's on self. It's on evaluator. Okay, okay. Oh, this is run from here. From command runner evaluator, yeah. It's like we should only have like one evaluator, right? I think. Okay. Like, why is that D reference like that? That looks weird. You don't need to do that. Was there a point in time where you actually had to do that? Or did I do that? Maybe I did it. No, I didn't. Stop it. It was the AI. No, it was me. No. 158. Oh man, this is gonna get hairy. I think this feels bad. Just this whole setup with all the command bridge and everything, and like I don't really understand how all this is set up, to be honest. I can't really see it clearly in my head, to be honest. So yeah. And yeah, I don't think it's not gonna help sitting trying to feel out the problem. It's just gonna be a tedious process of finding how the evaluator can be overwritten here. What the hell is this? Oh, this is the allocator of the race. I think there's no arenas going on here. There's only a bunch of oh, what the hell? We do have arenas here. What? Oh, this is the tests. Okay, let's get rid of this. Get rid of this shit here. What is this? Command executor. Okay, we need this. Fake handle, we can remove. Okay. Build pipeline block. There we go. Parser script executor. Is this test also? Yeah. Let's get rid of this test here. Fake handle. Alright. Document store, diagnostics. Right, okay, so there's no arenas. What is this? Like render string literal? What is this used for? Render string expression. This isn't even used. Oh, this is for the old stuff. I see. Yeah, I think it helps to like delete all this shit here because it can be very, you know, it's when you're trying to find things and how it works, it's like super annoying that you have a bunch of things that are not even used. See, now this is only like 200 lines of code here. Command runner. We have let's just remove all these tests. Copy own slice. Fine. Needs quotes. Who needs quotes? Clone bytes. Destroy captures. Okay, fine. The command display. Okay. Stage capture. Okay. Context. Cool. All right. Like this, I don't understand. Like the command bridge, why is it nullable? Why do we have this? Why is it? You know, what is this? I mean, I guess I could ask AI to explain. You know what? This could actually be a good thing for AI. Like, okay. We don't have any errors now. Let's do sig build. And we run this. And we have this error here. So I will copy this. We'll go in here. Let's do like max, or wait, maybe this. No, let's do this. Max extra high. Wow, they really but let's do medium here. Fix this error, or try to anyway. Oh. Wait, escape. Oh no. Why? No. Please stop. Fix this error. There we go. Alright, it's gonna do stuff here. I have little faith that it will actually find this issue, but you know, we might get lucky here. I guess in the meantime I will try to find it myself, but I just feel a little bit lost. I need to understand what's going on here. So we have like init with executor, init with runner. This why is it not going to the thing? Okay. Command executor run function context specs. No, that's a function, right? So the only thing you have is like the function and the context. So what is the purpose of this? This feels so you know, unnecessary, to be honest. And then it just like runs a pipeline on the command runner, so it makes it like already knows that this is a command runner, and then it just calls run pipeline. Like, what's the point of this? AI. Okay, and then we have like evaluator drive statements, version execution, AST blocks. It owns the allocator, use temporary things and formats, pipelines. To the command runner or an adapter on implementing a command. Okay, so it's like okay, maybe it's a thing of the past where I thought like it would need different things. Adapter implementing command executor. But it just okay. Fine. But you could just pass this function around. Like, this doesn't do anything. You're just passing this function around, and that's... I mean, I guess one thing, it does keep the context in here. And then you can just call run, and you wouldn't have to pass the context, because it would exist on the command executor. I guess that's what it's doing. It's basically just grouping those together, and you can run it without having it. I guess. Maybe, okay, maybe we'll move the evaluator to here. I don't want to change things now when AI is always doing stuff. Though, so I have to wait for this. But yeah, it would be cool to have this, like, you know, you do like function parse int, and you would take you know, I don't know really about the, maybe we don't even have parentheses here, maybe we have a special syntax here, maybe we have like I don't know, 0 int, 0 is an int, 1 is an int. There we go. There's a syntax for you. Maybe comma, or maybe just this. The first one is standard in, second one is standard out. No, that doesn't make sense. Maybe we have like standard in, standard out. Arguments. Is it changing things? Yes. Oh man, maybe I should have committed before. No, it's... Is it done? Okay. Could you please say what you did? I guess we can look at this maybe. Explored. Okay, so you added wire command bridge. And you call that. Okay, because we could maybe have different evaluators. Okay, it makes sense so far, maybe. It was in the area that I thought it would be, of course. Then you called it here, okay, and here. And here you do this. I'm not sure about this, but we'll see. Hook the command bridge up to a real evaluator. And cleaned up the function stage scope to stop the crash. Functions, okay. Script executed now exposes wire command bridge to point to the bridge back at its evaluator and is called after initialization. Right, and import, well, REPL we don't care about right now. And import setup in this. Also added a missing defer in scopes the init in runtime command runs of function stage. Look at this. So it actually is pretty good at SIG, I would say. It is pretty good. It just uses like an old version sometimes. So although you can try to tell it to how to actually do some of the things that has been updated, so you can give it like hints. You could like keep the, I think I have like downloaded the SIG documentation, so I have it here, but it doesn't really always look in there and try to use it. But maybe if you tell it to, but then I feel like it's also gonna like take more what's it called, you know, runtime from the AI. Also added missing yes, function stage like frames runs cleanly without no general protection fault. Next, consider running this for border bar. Okay, thank you AI. That was actually pretty cool. I'm just thinking about. Okay, to be for this not to be messed up now. I'm just gonna do this. So I don't overwrite anything, and then let's try this again. Hey, it works. Okay, now for the next test, thank you AI, that was actually pretty cool. For the next test we will do hello. So Will this work? Okay. That was underwhelming. What about if we do this h equals hello? What happens then? Okay, and then we will echo this. I don't think this will do anything because, well, yeah, because we set the standard out to be empty. Okay. I thought that this would, like, the whole thing was this would evaluate to like a process handle, and then that would be, since we're out in the outer scope here, it would actually go to be forwarded to standard out. Okay, let's fix that. That will be the last thing that I have to go here because my brain is starting to melt. Run script. No, wait. Evaluator. That's right. That is right. Okay, where are you? Where are you? Evaluate pipeline. This should be a process handle, yes. Wait. Evaluate identifier. Yeah. Okay. That will result in a function value, function declaration value. When we then store this here, we're looking, okay, we found a function, so then we run it as a pipeline. So that should be done. And I think that actually was done. And because otherwise we wouldn't have gotten those weird errors. But then we have this pipeline, and then we return this. This should be a process handle. Okay, I see. I see what's going on. I see what's going on. Actually, we run this. We run the pipeline. We run the stage. We run the function. And we just set this to 0. So I mean, we just set this here. So this is the issue. What's the issue here? So how do we fix that? We run the function. We need to be able to capture all of the standard out, the standard stuff happening in here in order for this to work. How do we do that is the question. Yeah, okay. It feels like we need some sort of context here. Okay. We need like a platform. A standard out, standard in platform for this to stand on, and then we kind of have the same logic as when we are forwarding. When we're forwarding this. Wait, this is the wrong place. Wait, no. Okay, that is the thing. When we're forwarding this, basically, this is like looking at all the statements. Well, it's executing statements, and we get the statement. You can see this as kind of the outermost shell of the thing. So whenever this gets a value that is a process handle, it forwards the output there. Right? Option standard out, standard error. So actually we could do an execute, to be honest. We could do an execute. Probably, yeah, we need to like do this here. Instead of like a function run, like only run block, we actually have to run execute. But then the script needs to be, I mean, I guess we could make a script from the function to be run. And we have to provide all this crap here. Like, is this even used? Is this even used? Because we're using the scope. Like, why do we have this? Should I just remove this? Okay, hang on. Well, we are gonna use like an empty context. I think... No, we can't. Actually, we have to... Okay, so actually we have to do like this, because if we have a function hello, another function hello 2, this is being run without a scope. Excuse me. So we can't do this right now. This is impossible right now. We need to, in order to do this, we have to have a scope here. We have to like inherit the scope of the parent. Okay. But that could be later. That could come later. Hello Polaris, how are you doing today? I'm good, doing pretty good. Thank you. How about you? It's just a lot with this language here. But it's pretty cool. It's like it feels like I'm breaking like new ground for me. So maybe we need to execute the function with this execute instead. That does seem like a correct thing. Because that will be like some kind of recursiveness to it. Like we call this function from within to execute a function. Because that will handle like standard out, standard error. And pass that through, like forward that through in a correct manner, and wire up everything like it should. The only thing is the only thing I'm thinking about is maybe we need to like change this so that, because this goes for scopes here. I guess we could push a frame like a blocking frame, then execute, and then pop the frame. What are we using for options here? Standard error, script path. So we're not actually using the bindings of the options. Okay, that's cool. We also have script path. Yeah, okay, script path. That should be like the original path where the function was declared in. We actually don't have that information in the declaration. Interesting. Wait, do we have that in the span? No, we don't. Okay, should we just try this then? We should just, yeah, okay. So where do we do the thing? So we have evaluator, run function, right? Okay, this is called from command runner. That it could be fine, I think. We don't have the executor here. So if we call this, do we have the executor here? But that's the command executor, not the script executor. Oh, man. And that's the command bridge. Wait, where is this? Runtime? No? Where do you exist? Actually, let me just go to command bridge. You have the runner evaluator. Okay, so we don't actually have like the executor. Okay, so maybe we can't run execute, but we would want to run this function. Maybe we should move this to the evaluator. Maybe. Okay. What do you use? What do you actually use? Like evaluator, scopes? I mean, we could also just create a new executor, maybe. It's gonna be too much. Actually, maybe we need an executor for each. Wait, we do have. Wait. We have an executor for each document. So we'll find the we'll find a document. Oh, and wait. Hang on. You have the document store. So we'll just grab the document that the function is declared in. Then we have the script executor for that function. We can just call execute with that. Yes. Okay. Now, the only thing we need hang on, yeah, we're gonna need, like, in the function declaration, we're gonna need where does this come from? We have span with location, but this doesn't tell us the file actually. This should maybe include the file. That's gonna be so many changes though. Maybe. Like if I add file here. Oh, maybe not that many actually. Wait. Hang on. Okay, I guess we can store the file name here. And then init with source. Let's also add file name. Yeah, I mean it's gonna be a bunch of changes, but we need it. Maybe not as many as I thought though. Init. Actually, we have path here. Is this is what is this? The parser? Yeah. Wait, is that true though? Is this the correct one? Parse script path. No, it's just path. Yeah. It's path. There we go. And for that you need parse source, right? So this one is different, like, because we don't actually have a file name here. And you print script tokens, script path. So this would just be script path. There we go. Wait, was that really that easy? Okay, so now all tokens should include the file now in the location. It's kind of weird though, because technically this is not really an issue, but technically it's kind of weird because start and end could technically be in separate files, which doesn't make sense at all. But so that's kind of funny. But whatever. Can I actually run this? Oops. Yes, I can. Okay, cool. So now we have that information in the thing. Yeah. So to get the file, we just need to say span start file, and there's our file. And now we can use that to get our document. So we can get the document from self document store, and then request document file. Or we don't really request a document. What we do is we say map get get, and then this is gonna be function declaration span start file, and I'm just gonna unwrap it because it has to exist. So there we go. Now we got our document. Now what we can do is we can get the document, we can get the executor of the document there, and it has to exist as well. Now we can use executor.execute, and we need to build a script, so whatever, let's just do span whatever, let's just do that span, and then the statements, I think. Why? Well, it's gonna be the function declaration body block statements. Okay, I guess it's if it's a block we can run it here. So we just execute it. Instead of running these things, we will execute it. Yeah. And then we get like an exit code. Huh. Okay. And then we have like options. So now we can say like options standard out. So this will wire up to, what the hell was, okay, where would this go? Actually, you know what? Wait. Why is, okay. So there's no way of getting the current document. That should really be stored here. We should store the current document here. Do we have it anywhere? I don't think so. So let's just store the path here as well. And now we need to add that. So each executor is gonna have one, you know, document, so that's fine. What do you have? Do you have script path? No. Runner. Alright, let's just add this because you don't have it. No. And this is the enter document, so this will be enter document dot path. There we go. Now we have that. Oh. This would be like this would be document dot path. There we go. Oops. What is this now? Oh, that's just that. Okay, and you. This is, I think, the REPL or something. No, session. What the hell is this? Yeah, it's the REPL. Okay. So this would basically be like, you know, source something. Okay, cool. So now we can get the current document with document store, map, get, self, path, and there we go. And what does that give us? We have current, well, it gives us current document, script executor, question mark, and maybe like, I don't know, command bridge. Do we actually store anything anywhere? Like the out, like the standard out, standard er. Where do we pipe this? Where do we map this to? So if you're running from the outermost context, we pipe it to the process standard out, standard er. And if you call a function, those should also be piped to that. I think it's basically going to be like an onion. You call a function unless you redirect to something else or pipe it or do anything like that. The context is just gonna wire it up to the previous executor. So we do need to like the current like execution context. We do need to store that actually. Should we store it here in the evaluator? I think so. So when we do like execute, you actually have like execute options. So these I want to store in the evaluator. So this would be like execute options. That comes from script executor. But it's not available. Actually, it's just it is available. It's just that it's on script executor. There we go. Okay. Now we should get some errors somewhere. There we go. So the evaluator needs execute options. And we'll put it there. No. And then you need execute options as well, which actually just exists. Now you so these are the options. Is this gonna be an issue? Wait, this is a point. I mean, that's fine. All right. Oh. Yeah, okay, same thing here. Oh. Okay. Let's move you over there. Context. Let's just see if okay. Cool. Good morning, Zaflins. How's it going? I'm gonna quit soon here because my brain will stop working in like 2 minutes. Current doc. What? Oh, wait. This is the wrong place. Here we go. You are annoying as well. Wire command bridge. Wait, what? Oh, okay, that, sure. Wait, wire command bridge? Oh, so you're not actually executing anything? Okay. I mean, whatever. I'm just gonna put undefined here, just because, yeah, the repo stuff is not gonna work for a long time. Slept for like 10 hours. Holy crap. That sounds amazing. I wish I could do that. But there's always something interrupting. I don't know. Like I don't know how long ago it was that I could actually sleep through an entire night without like waking up at some point. But that's awesome. That's awesome for you, man. Let's see. How do I do this? Wait, what is the issue here? I'm just, you know, I don't know what I'm doing here. Expected type found constant. Interpreter script executor. Are you a constant? Oh, I guess, but you are that, so you can do this. There we go. Yeah, that looks way more correct. Or you could just do document script executor directly, but yeah, we don't want to create a copy and then modify that. I don't think. Maybe. Maybe not. I don't know. No, actually, you know what? what we want to do is we want to also go to scopes and push a blocking frame. And then here we want to pop the frame. Because, or wait, no, it's not blocking. Wait. No, it's not blocking. But well, we want to push a frame at least, because this might declare a bunch of you know, variables and stuff. That should be local to it should be its own scope, you know. So I want to, just to make sure, we want to have a frame here. But it's not going to be blocking, because then you can't access things from outside. So let's do that, maybe. Okay. Okay. Try the, yeah. So. Okay, now stand it out, stand it in. Stand it out, stand it in. What do we do with this? Oh yeah, so now we have like current document, executor, yeah, we actually have like evaluator, execute options, standard out. So we'll wire it up to whatever the document that is currently, or the context that are currently calling this function. Whatever standard out that is having, we will like write to the same standard out. So we're wiring it up to the same thing. Same with what? Same with this. Okay, what are you missing now? What? Oh. There we go. Script path, context. I don't think context is used. So I will just set that to undefined. And then the script path we have, that is going to be document dot path. And the context I'm just going to set to undefined, because I don't think that is actually used here. Like if you look at this, options, only these are used, this, and nothing else. So the context is like, it doesn't exist. Okay, wow. However, we only get like an exit code out. I guess that's fine, really, because the actually, yeah, we don't need the process handles. This is gonna take care of the one. Yeah. All right, let's do this, and we'll return something, I guess. I mean, okay, I guess we do want to have a process. No, actually, no. This value is gonna get thrown away, actually, by the other thing. The pipeline runner. Okay, so it's kind of weird. When we encounter a function call, we will run it as a pipeline, which in turn will call this function to run it as its own kind of script with the scope and everything. Wire up all the standard out, standard error. We don't actually capture standard out, standard error in the pipeline though, so that is an issue. I need to figure out how to do that. But basically here we just return a void value, so we don't actually have anything here. This one we don't care right now. I just want to see if this works now. This feels very hacky the way I've done it right now. It runs. I mean, it builds. I mean, so let's open up this and let's see. Yeah, okay. Attempting to use a null value. What? Okay. Let's see. Wait, where is this happening? Is it here? Or yeah, it's probably here. Evaluator 18, 118. No. All right. So documents, file. So let's log this out. Run function. Function declaration spans. Start file. All right. Test RN. All right, that's we need to resolve it then. Why is it? All right, let's just resolve it, I guess. Actually, it should be correct from the start. Yeah, it should be correct from the start. Where is this being set? Like the Lexer? Lexer file. No, not the LSP. Yeah, it's been set from here. Which is being set from here. Which is being set from... Well... here, yeah, and the path is wrong. Resolve path. We need to call this function here, resolve path. Self path equals path. This one, the stream. Okay, we need a resolve path equals to. Let's do doc. Wait. Oh shit, we don't have it. Well, you know what? Let's just pass in the absolute path here instead then. Okay, apparently we no, that's the LSP, right? Where are we running this? Run script, that's right. Script path. Entry. Wait, document store. Oh. Let's make this public. Result path. Script path. Defer. Wait. Are you using the arena or what are you using here? Yes. So now we don't need to. Okay, we don't actually need to. Deinitialize it here. Okay, there we go. So we got the result path and we set it there. Hey. Okay. Wait, it works. What? Wow. Okay. Holy shit. Okay. Yeah, okay. It works. Wow. Okay. Okay, can we call it again? Hello. No. What? Man. Why not? Wait, why not? Okay, you know what? This is I'm gonna set AI on investigating this. So, but in the meantime, I am actually going to call it now because I can't think straight. Can I get out of this one? Oh, this should be a new one, yeah. Alright, investigate why Runic test RM does not print hello 2 times. Since we are calling hello 2 times, it only prints it once. Alright. I'll put AI to work there, but yeah, that's gonna be it for this time. So thank you very much for joining me, and let's see what we can tick off here. So functions, I mean, it works, but there's a bug. Bug cannot call functions more than one. Also, there's a lot of things to do with functions that we don't have, but there's too many, so I'm just gonna write it down here, but we'll figure it out. A lot of things missing, so it's like, you know, standard in, standard out, like pipes, you know, what else, like standard error capture, well, I guess we have, yeah, no, so standard out, so standard in, standard out, capturing and piping, like this. What else? What else is there? Like return statements? I don't know. There's a whole bunch, etc. So there's like a whole bunch of stuff with functions that we could do, which would be really cool if it could work. And also it would be really cool if we could like wire up some type checking. Maybe we'll do that next time actually.
try to do some rudimentary type checking, like type expressions and type checking and stuff. That would be really cool. But yeah, that is gonna be it for this time. So yeah, thank you very much for joining me, and I will see you later.